terendah lagi
ഹലോ, അതെ, കൺട്രോളർ ഒരു വന്ന് ഒരു 10 മിനിറ്റ് എടുക്കുമെന്ന് പറഞ്ഞിട്ടുണ്ടായിരുന്നു. ജസ്റ്റ്
കൺട്രോളർ ഇപ്പൊ ജോയിൻ ചെയ്യുമെന്ന് പറഞ്ഞിട്ടുണ്ട്. സോറി ഫോർ ദ ഡിലേ.
Good morning, Dambuta.
Hello, welcome, Vincent. Hello.
Shall we start?
Welcome, Vincent. ജസിന്ത ടീച്ചറെ
Yes,
എത്തിയെന്ന് തോന്നുന്നു. എത്തിയിട്ടുണ്ട്.
okay.
കൺട്രോളർ
Yes, let us start, Vince. Let us start.
okay അല്ലേ?
Yes.
സാറിന്റെ ഓഡിയോ കണക്ട് ചെയ്തില്ല, കണക്ട് ആയില്ല. വിൻസെന്റ് സാറിന്റെ ഓഡിയോ കണക്ട് ആയില്ല.
ഹലോ. ഹലോ വിൻസെന്റ്. ഹലോ. ഹലോ വിൻസെന്റ്, വെൽക്കം.
സർ, അദ്ദേഹം ഓഡിയോ കണക്ഷൻ കൊടുത്തിട്ടില്ല.
ഓഡിയോ
കേൾക്കില്ല. ഓഡിയോ കണക്ഷൻ കൊടുക്കാതെ കേൾക്കില്ല.
മെസ്സേജ് അയച്ചോളാം. ഹലോ, വെൽക്കം സർ.
താങ്ക് യു മാഷേ, താങ്ക് യു.
തുടങ്ങാലോ നമുക്ക് അല്ലേ?
തുടങ്ങാം മാഷേ, തുടങ്ങാം.
Okay, Mr.
Yes.
Good morning. A warm greetings to one and all. First of all, I extend a very sincere welcome to all of you present here on this webinar ASTERISK. I am Anamika PM of second year BSc Mathematics of St. Joseph College, Platara.
And I'm Sandra Prabhakar of third BSc Mathematics of St. Joseph College, Pilatra.
As we all know that we are going through a pandemic situation. This is for the first time our Department of Mathematics is conducting a webinar series on a digital platform. I would like to convey my heartfelt gratitude to all the VIP guests for accepting our invitation and presiding over this webinar. Our department has come with an idea of a series of talks on the subject mathematics and will be continuing in the coming months. We select this day to begin with a general talk, and from tomorrow we will be dealing with topics in mathematics. Once again, I thank all for taking time out and being here today. Let me share my schedule of today's webinar. Firstly, I invite Professor Ms. Jacinta Luca, Head of Mathematics Department, to deliver a welcome speech.
Good morning to all. Respected Principal, Dr. K.C. Muralidharan, Bishop, Your Excellency, Most Reverend Dr. Alex Vadakundala, Controller of Examinations, Dr. P.J. Vincent, our resource person, Dr. Joe Jacob, Right Reverend Monsignor Clarence Paliat, Dr. Joy Painadath, Reverend Father Johnson Smith, Reverend Father Shijo Abraham, faculty members from our college and from various colleges, dear participants and my dear students. On behalf of the Department of Mathematics, St. Joseph's College, Pilatra, I extend a very warm welcome to all of you present here to the webinar ASTERISK. The department proudly begins its webinar series with the topic Beyond the Stars. It aims to create an interest in research work among the participants. Tomorrow, we are having a session on mathematics, a subject to memorize, by Dr. Bajil Tien of Sussex College, who did his post-graduation and PhD from NIT Calicut. At this function, it is my happiness, satisfaction, and duty to welcome you all to the modest function. Firstly, I am eager to welcome Dr. K.C. Muralidharan, our principal who presides over this function. Welcome you, sir.
Thank you. Thank you. This is the miss.
With utmost gratitude, I welcome our beloved Bishop, Most Reverend Dr. Alex Vadakuntala, Your Excellency. Indeed, we are highly excited to welcome you in our midst to support us and bless us. I would like to take this opportunity to thank God for your life of selfless service and tremendous sacrifice to the Diocese of Kannur. Hearty welcome you, my Lord. I consider it a great honor to welcome Dr. P.J. Vincent, Controller of Examinations, Kannur University. In spite of his busy schedule, he spared time to inaugurate this webinar. Hearty welcome you, sir.
Thank you.
Next, I welcome our resource person, Dr. Joe Jacob. He is a member of the team in the discovery of the supercluster Saraswati. I welcome you, dear Joe, sir.
Thank you, teacher.
I also welcome Right Reverend Monsignor Clarence Palliot, Vicar General and Corporate Manager of Kannur Diocese and formal Principal of St. Joseph's College, Pilatra. I welcome you, dear Monsignor. I welcome Right Reverend Dr. Joy Painadets, our manager, Reverend Father Johnson Simeti, Vice Principal, Reverend Father Shija Abraham, Assistant Manager to this function. I also welcome all the faculty members from our college and from other institutions, administrative staffs, and all the participants within India and abroad, and dear students to this webinar, ASTERISK. Once again, a hearty welcome to all of you. Jai Hind.
Thank you, ma'am. Next, I welcome Dr. K.C. Muralidharan, sir, Principal of our college, for the presidential address.
Thank you, Anamika. His Excellency, Most Reverend Dr. Alex Vadakundala, respected Controller of Kannur University, Dr. P.J. Vincent, Monsignor Clarence Palliet, Vicar General of Kannur Diocese, Dr. Joe Jacob, our resource person today, Professor Jacinta Luca, Head of the Department of Mathematics, our Manager, Father Joy Painadath, Assistant Manager Shijo Abraham, our dear Vice Principal, Father Johnson Simeti, heads of various departments of St. Joseph's College, faculty of St. Joseph's College, faculty from other colleges, and the 173 participants in this webinar. Welcome to this function. It was on July 20th, 1969, that Apollo lunar module Eagle landed on the moon. And today, I think the Department of Mathematics takes us to the stars. It's a very happy moment for us. This is the fourth webinar conducted by the college in this times of difficulty imposed by the pandemic, COVID-19. And we have addressed the challenge of the pandemic very successfully at this seminar, yes, this webinar tells us. We are here to listen to one of the very eminent scientists of the space who was part of the team that discovered a supercluster, which they named as Saraswati. So, from time immemorial onwards, we can see that certain things in nature, certain aspects of universe always inspire all living things, including human beings, right from their origin. If we ask a question, what is the most important thing in the world? The answers would be like the ocean, the infinite skies, or the sprawling landscape. Why do these things attract human beings as well as all living creatures? Is a very important question to ask. No man, no human being, no animal wants to be tied and kept in a narrow room, narrow space, or cage. And that is why our imprisonment, solitary imprisonment, is rigorous imprisonment. They understand, sentenced persons understand freedom when they are behind the bars. And people at large in this pandemic times became some sort of, confinement, underwent some sort of confinement in the name of quarantine, home quarantine or quarantine in institutions, telling us again and again about the expanses, the freedom to enter the spaces, the freedom to enjoy the seas, the oceans, the vast skies, etc. For religion, for cultures, for every human being, infinity, especially for mathematics, infinity is a very dear concept. How can we taste the infinity? Is it possible? If that question is raised, I would say infinity can be, we can get a taste of infinity when we look at the sky, when we watch the seas, oceans, endlessly sprawling, spreading oceans, and the landscapes from a cliff. All these give us a taste of infinity. So this may be why people from the origin of humanity interested in what we usually call nature, sky, and ocean, water bodies at large. സാധാരണ നമ്മൾ മലയാളത്തിൽ പറയുന്ന ഒരു കാര്യം, നമുക്ക് ചെയ്യാനുള്ളത് ഒന്ന് മനുഷ്യന് നേരെ നോക്കി സംസാരിക്കുക എന്നുള്ളതാണ്. മറ്റൊന്ന് ലുക്കിംഗ് അറ്റ് ദ സ്കൈസ്. അത് പല രീതിയിലുണ്ട്. വെൻ വി ആർ ഹെൽപ്ലെസ് വി ലുക്ക് അറ്റ് ദ സ്കൈസ്. മാനം നോക്കുക. എന്താ മാനം നോക്കി നിൽക്കുന്നത് എന്ന് നമ്മൾ സാധാരണ പറയാറുള്ളത് അതുകൊണ്ടാണ്. എന്തുകൊണ്ടാണ് മാനം നോക്കി നിൽക്കുന്നത്? When people are helpless, they have to look up. And when people are in despair, they look down. And that is looking down has various meanings in English. Looking down means despair. Looking down means, looking at people as inferior. Various ways of interpretations are there. So anyway, human beings looked at the skies with various emotions. We can see a matrix of emotions, a wide range of emotions, spectrum of emotions like fear, curiosity, sense of beauty, despair, great artistry, and again, some looked at the skies with logic and reason. And this has been part of all the aspects of human culture. And it is said that the idea of the heavenly bodies moved people, moved different cultures to shape what were called the wonders of the world, like pyramids of Giza, Stonehenge, vast constructions. All these come from our idea of the heavenly bodies. And we also see things, patterns in heavenly bodies, like the proverbial young or baby rabbit in the moon, some human form, man in the moon it is usually called. So from time immemorial we have this kind of seeing patterns in heavenly bodies, in things and objects around us, so that we always conceived religiously, conventionally, a three-tier world: a world up, the middle world, and the underworld. Underworld is a place of spirits, snakes, Nagaloga. In Hindu mythology it is called Nagaloga. The upper tier is definitely for the divine people. We always connect stars and other heavenly bodies to our day-to-day life. One example is the name of the days that we have, right from Monday to Sunday to Saturday. We have the names of various heavenly bodies giving us the days of names. There's a very interesting story about all this tells us that people were connecting heavenly bodies to their day-to-day everyday life. And talking about stars, listening to talks about stars, we are coming back to the real, the everyday. There's a story in Hindu mythology about Dhruva Nakshatra. It goes like this. King Manu's son, Uttanapada, it was his name, had two wives. One was Suruchi and the other was Suniti. The Suniti was, the new wife. And naturally the king was more associated with Suniti. Both of them had one son each. Suruchi's son was Uttama and Suniti's son was Dhruva. As we all know, there is sibling rivalry among these children, young ones. And Dhruva was once sitting in the lap of Uttanapada, and Suniti didn't like this. She pulled away the son, the other wife's son, and he was embarrassed, and he took a strong decision to go to the forest and do penance. And he spent 6 months in penance, pleased God, and later ended up, as we all say, the pole star, Polaris, very bright and consistent star, which is, we can say now, was the ancient GPS based on which people made their journeys, travels. We also, read about in Christian scriptures, the three wise men followed the star to Bethlehem, from Jerusalem to Bethlehem, to witness infant Christ's birth. And these religious scholars, known as Magi, is now understood as people like Professor David Hughes, astronomer, sees them as ancient astronomers who watched the sky, and if they saw something unusual, interpreted it as omens, certain omens that would affect and influence the life of people on earth. So it was said that these magi, these wise men, actually understood the alignment between the sun, the earth, Jupiter, and Saturn, usually called the triple conjunction. And that was what made them reach the place where Jesus was born. So all these, and in the case of Islam, we always see, crescent is very important to them. All their festivals are related to the different waxing and waning of the moon. And this is what is called archaeoastronomy, ancient astronomy, which cannot be rejected as nonsense or unscientific. It is from this we have developed into what is called the present modern astronomy, through which our speaker today was able to do a lot in even discover a star which was 400 crores light years away from us. And though we are very advanced, use sophisticated technology, we often fall into the primitive, conventional mode of understanding also, very often. I would stop with a few lines from Nalapattu Narayana Menon, his elegy upon his wife's death. It is called Kannunir Tulli. ഒരുവിധം എല്ലാവർക്കും അറിയുന്ന ഒരു വിലാപകാവ്യാണത്. അദ്ദേഹം 1954 മരിച്ചത്. 1887 ജനിച്ച് 1954 മരിച്ചത്. 1954 എന്ന് പറഞ്ഞാൽ പക്ഷെ ചന്ദ്രനിൽ മനുഷ്യൻ ഇറങ്ങിയിട്ടില്ല എന്നുള്ളതാണ്. അപ്പം അദ്ദേഹം അതിനെക്കുറിച്ച് പറയുന്നത്, അതിലെ ആദ്യത്തെ വാചകങ്ങൾ മുഴുവൻ, ആദ്യത്തെ വരികൾ, കവിതയുടെ വരികൾ മുഴുവൻ ഇത്തരത്തിലുള്ള ഒരു പ്രാചീനമായ ഒരു ലോകത്തെ കാണിക്കുന്ന വരികളാണ്. അതിൽ ഏറ്റവും പ്രധാനമായ 4 വരികളാണ്: അനന്തമജ്ഞാതം അവർണ്ണനീയം ഈ ലോകഗോളം തിരിയുന്ന മാർഗം, അതിൽ നടുക്കെങ്ങാണ്ടൊരിടത്തിരുന്നു നോക്കുന്ന മർത്യൻ കഥയെന്തു കണ്ടു എന്നാണ്. The helplessness of humanity in a very vast, infinitely vast and expanding world. We often retreat to that helplessness when our existential issues bang on us. But there is science on one side, there is spirituality on the other, to lift us again and help us address these issues. So there is a shuttling between our ancient notions and the modern notions. Now even after discovering Saraswati. I think our speaker today, Professor Joe, to Professor Joe, and all of us alike, this universe is still a mysterious place where there are many more things to find out and many more things to observe, many more things to connect to human life. And let the mathematics department, its seminar on this topic, Beyond the Stars, actually tells us something that we have to go beyond whatever we have discovered. New horizons are there. The pole star is still there, directing us through our travels through different disciplines. Let me conclude the speech congratulating the Department of Mathematics for hosting a seminar, bringing enthusiasts, aspirants, and knowledge seekers from India and abroad, different parts of Kerala, and also bringing together very eminent persons like Joe Jacob, who was, I think, who took his college, Kerala and India, to greater heights by by being part of the team that discovered a super, cluster, a super cluster. It has, I think, 42 clusters. It's a cluster having 42 clusters, a huge, unthinkably huge, uh, super cluster. Let us have a fine day. Uh, Best wishes to all of you. Thank you.
Thank you, sir. That was really an inspiring speech. Now, I invite the Most Reverend Dr. Alex Vadakuntala, Bishop Diocese of Kannur, and he is also the patron of St. Joseph College, Platara.
Can you see the slides now?
No, Father.
Not yet.
Not yet.
You have the screen.
Hello. Yes, I think it's coming. Yes.
Okay.
Now, visible.
Dear Dr. Muralidharan, who is presiding of this webinar and the principal of St. Joseph College, Pilatara, Dr. Joe Jacob, a member of this team that identified the supercluster Saraswati, and we are looking forward to listen to you, dear Sir Joe Jacob. Dr. P.J. Vincent, the controller of exams of the University of Kannur, Monsignor Clarence Paliath, the former principal and now the Vicar General of the Diocese of Kannur, Dr. Joy Painadat, the manager of the college, Reverend Father Johnson Simenti, the vice principal, Reverend Father Shijo Abraham, the assistant manager, Ms. Jacinta, the HOD of the Department of English of this esteemed institution, and Ms. Megha, the assistant professor, and all the faculty members, esteemed participants, students, parents, and everyone. First of all, at the outset, let me really congratulate Mr. Sinta, the HOD, and the entire team for this webinar. And from mathematics, they are taking us up in the skies. Moreover, last year, The Department of Mathematics was identified as the best department in the entire university because of the 100% result and also the remarkable achievement that they had. I'm sure this year, through this webinar and this hard work, you will continue to uphold the same prestigious tradition which you had held a couple of years back. The battle against COVID-19 continues in our country, with the number of positive cases and resulting deaths rising in India every day. A lot more attention is needed to curb the further spread of this pandemic that is affecting every sphere of our life, including education. But I would like to congratulate the management staff of St. Joseph's for their creativity, innovation. In spite of all their odds, they have their regular classes online. And moreover, added to this, like this, different departments are having webinars. And today, this webinar conducted by the Department of Mathematics. In fact, in the title which it really interested me, the title. And I was happy to listen to Dr. Muralidharan in his scholarly, inspiring presidential address, where he connected how important this reality, which is far above us, how different religions, Hinduism, Christianity, Islam, and so on, are influenced, and how it influences even our everyday, the week when which we call, each day we call after one of these stars. The word asterisk derives from the Greek word asterikos, which means a little star. The word has been a part of the English, the constellation of English language since 1300, so almost 700 years. And the Greek forms of aster, astro, or astrum, all of which mean star, still cast their light in English. For example, words as asteroid, astral, and incidentally even disaster, which originate, because why the term disaster is connected with the stars, as Dr. Muralidharan just explained. The unfavorable of aspect of a planet or star or influences very much on the earth or in all the aspects of life. So even a star itself is a distant relative of asterisk. Very meaningful to have chosen this title, Beyond the Stars, for this asterisk series of webinar by the Department of Mathematics. We should be happy and proud that Dr. Joe Jacob, I congratulate him, especially being a member of the team in the discovery of this supercluster Saraswati. I have a friend of mine now living in France. His name is Agop Tersan, in whose name there is a star. We were part of an organization called IRIS. IRIS is an acronym of a French name, which means interdisciplinary research in various disciplines. So he was there from astronomy. I was there as an Indian Christian specialized in canon law and so on. So from different words, different fields of specialization, they came together. And once we had the theme, man and his roots. So each one looks at that theme from different point of view. So Agop Tersan, this great astronomer, who from a star, how he looks at a human person living on earth, and his reflection, I still remember so vividly how important for us to reflect as from a star, looking at the human being. Who are we? As Dr. Muralidharan quoting Nalapat, he said, "Manushante kadhe endariva." So what are we in front of all these constellation? You know, this may be an interesting piece of information for you. There are 11 Jesuit priest scientists community among the stars. Means there are 11 stars are named after some Jesuit priests. And the last being Father Christopher Corbelli. He is the director of the Vatican Observatory. And the first star is named after Saint Ignatius of Loyola, the founder of this Jesuit order. Perhaps you may remember Father E.J. Thomas, in whose name we are named after the library of St. Joseph's College, one of the Jesuit members who was the pioneer, together with Father Clarence, to build up St. Joseph College. As members of the faculty of Department of Mathematics, I also would like to mention this name of Reverend Dr. Anthony Connolly. He was he is the former principal of St. Albert's College in Ernakulam. He was a great mathematician, and perhaps you must have also learned this theory, Connolly's theorem, found out by one mathematician, a priest, Anthony Connolly, whom actually originally I belonged to that diocese, so I used to look up to him with great regard, the scholarly father. I just wanted to say that, yes, this study or connection between mathematics and astronomy is something interest for us to reflect upon. The great philosopher Immanuel Kant has this beautiful expression which says, two things I wonder at: the starry heavens without and the moral conscience within. The starry heavens, we do not know how, as Dr. Muralidharan mentioned, Dr. Jacob found out this supercluster 42,000. I don't remember the exact measurement, but then such far away the stars. So when we reflect about this, the constellation, we really wonder at the starry heaven. And also there is our moral conscience, which is important. There's a German phrase, auf der Erde stehen und die Sterne streifen. That means we have to stand on our foot, keep our foot here on earth, and we should also try to touch the stars or hold on to the stars. So our minds and thoughts and have to go up to the heavens. In fact, I mentioned about the 11 Jesuit priests. The first one, which is named after Saint Ignatius of Loyola, who said, ad contemplatio ad mai amorem. In Latin, he said, that means we have to contemplate, meditate on this starry heaven and love the entire universe, including this nature. The greatness of mathematics is this: there is no ambiguity. 2 + 2 is 4 everywhere. There is not 4.5, it's not 3.5, it's 4. So there is no ambiguity. Everything is clear, compact, and definite. Perhaps when we study about the mathematics, it should also influence our lives. John Kepler, the great scientist who lived from 1575 to 1630, Johannes Kepler says, scientists as ministers of the book of nature. So when, as students of mathematics or teachers of mathematics, when we think about these stars, the nature, we should also we should love this earth and be ministers or protectors of this nature. It was the great philosopher, Danish philosopher, the father of existentialist philosophy, Soren Kierkegaard, who said, God of Mercury asked him, it seems, what do you need? Because the stars are so powerful. So he also asked, what do you need? Power or youthfulness, gold, women, whatever. But Kierkegaard's reply was, bless me so that I can smile, I can be joyful. So more important is for us to have a life always joyful, peaceful. Looking at the stars, we should wonder at the starry heaven, as Immanuel Kant mentioned. At the same time, we should look into our moral conscience so that we can be better human beings. Teaching and learning is always a matter of interaction. Can our teaching of mathematics makes us means teachers, students, and everyone in the society better human beings? I wish this webinar every success, and may this reflection bring us to love this nature much more, and also look and appreciate this moral conscience within. Once again, I congratulate the Department of Mathematics, and also in a special way, we are privileged to have Dr. Joe Jacob, and we look forward to listen to him about his great contribution to the astronomy and also mathematics and to the humanity. Thank you so much, and all the best.
Thank you, Your Excellency, for your blessings and inspiring speech. Now, moving to the inauguration section, I humbly invite our honorable guest, Dr. P.J. Vincent, Controller of Examination, Kannur University. Dr. P.J. Vincent completed his graduation in history from Sir College, Talipramba, and he pursued MA, MPhil, and PhD from Calicut University. He was the head of PG Department of History at Government Arts and Science College, Calicut. He also worked on deputation as Press Secretary to Honorable Speaker of Kerala State Legislative Assembly. He was the editor of Government Arts and Science College Research Journal and has 20 research papers and more than 250 popular articles at his credit. He has written extensively in English and Malayalam, and his major books are A History of Kunnumal Village, Adiniveshathinte Asurakandam, Adinivesham Pratirodham, etc. He also edited books like Porkalam, History of K.M. Panikar. I welcome you, sir, for the inauguration.
Thank you for the kind introduction. Marathanaya Bishop Dr. Maya, Principal Muralidharan sir, Mathematics Department in the head I Pravartikina Jacinta Luca teacher, Saraswati in the cluster Kandatia, Pramukhanaaya Shastrajan, Professor Joe Jacob, Mate പ്രമുഖരായ വ്യക്തിത്വങ്ങളെ ഈ യോഗത്തിൽ പങ്കെടുക്കുന്ന ഈ വെബിനാറിൽ പങ്കെടുക്കുന്ന പ്രിയപ്പെട്ട വിദ്യാർത്ഥിനികളെ, എന്നെ ഇത്തരം ഒരു യോഗത്തിലേക്ക് വിളിച്ചതിൽ ആദ്യമായി നന്ദി രേഖപ്പെടുത്തുകയാണ്. ബിയോണ്ട് ദ സ്റ്റാർ എല്ലാവരെയും ആകർഷിക്കുന്ന ഒരു ടൈറ്റിലാണ്. 4 വർഷം മുമ്പ് ഇറങ്ങിയിട്ടുള്ള വളരെ 3 വർഷം മുമ്പാണ് തോന്നുന്നു, വിഖ്യാതമായ ഒരു ഹോളിവുഡ് ഫിലിം ഉണ്ട്, ഇന്റർസ്റ്റെല്ലാർ എന്നാണ് സിനിമയുടെ പേര്. അത് ആ സിനിമ കണ്ടിട്ടില്ലാത്ത ഈ വെബിനാറിൽ പങ്കെടുക്കുന്ന എല്ലാവരും അത് കാണണം എന്ന് ഞാൻ അഭ്യർത്ഥിക്കുകയാണ്. ഒരു നക്ഷത്ര ലോകത്തെ കുറിച്ച് നമ്മൾ സാധാരണ നക്ഷത്ര നിരീക്ഷണശാലകളിൽ നിന്ന് ലഭിക്കുന്നതിൽ നിന്ന് വ്യത്യസ്തമായിട്ടുള്ള ഒരു അനുഭവം അതിനകത്തുനിന്ന് നമുക്ക് ലഭിക്കും. ഏതായാലും നക്ഷത്രങ്ങളും ഗ്രഹങ്ങളും ക്ഷുദ്രഗ്രഹങ്ങളും മനുഷ്യരും ഒക്കെ ചേർന്ന ഈ പ്രപഞ്ചത്തെ കുറിച്ച് മനുഷ്യൻ എന്നും അന്വേഷിച്ചിരുന്നു. പ്രപഞ്ചത്തിന്റെ ഭാഗമായിട്ട് ശാസ്ത്രീയമായ അറിവുകൾ അവൻ ശേഖരിക്കുകയും ചെയ്തിരുന്നു. യൂറോപ്യന്മാർക്കും വെസ്റ്റ് ഏഷ്യയിലുള്ള മറ്റിതര ജനവിഭാഗങ്ങൾക്കുമൊക്കെ സൂര്യ കേന്ദ്രീകൃതമായ ഒരു ലോകം, പലപ്പോഴും ഭൂമി കേന്ദ്രീകൃതമായ ഒരു ലോകം ഒക്കെയാണ് സങ്കല്പങ്ങളിൽ ഉണ്ടായിരുന്നത്. എന്നാൽ അതിനേക്കാൾ എത്രയോ സഹസ്രാബ്ദങ്ങൾക്ക് മുമ്പ് തന്നെ പ്രപഞ്ച കേന്ദ്രീകൃതമായ ഒരു ലോകത്തെ സങ്കല്പിക്കാൻ കഴിഞ്ഞ ഒരു ജനതയാണ് ഭാരതീയർ. ചരിത്ര വികാസത്തിൽ എപ്പോഴോ നമുക്ക് ആ വിജ്ഞാനം നഷ്ടപ്പെട്ടു. അതുകൊണ്ട് വേണമെങ്കിൽ ആസ്ട്രേലിയയിലെ ആദിവാസികളെ കുറിച്ച് ദി സ്റ്റോളൻ ജനറേഷൻസ് എന്ന് പറയാറുണ്ട്. കാരണം അവരുടെ സ്വാഭാവികമായ ജീവിത സാഹചര്യങ്ങളിൽ നിന്ന് പിടിച്ചു കൊണ്ടുവന്ന് അവരെ സംസ്കൃതരാക്കാൻ വേണ്ടി ആസ്ട്രേലിയയിലെ സർക്കാർ ശ്രമിച്ചതിന്റെ ഫലമായി ചരിത്രത്തിലും സംസ്കൃതിയിലും വേര് നഷ്ടപ്പെട്ട ഒരു ജനത അവിടെ രൂപം കൊണ്ടു. അവരോട് ക്ഷമ പറഞ്ഞുകൊണ്ട് അവരെ തിരിച്ച് അവരുടെ ഭൂമിയിലേക്ക് അയക്കാൻ ഇപ്പോൾ സർക്കാർ തയ്യാറായിരിക്കുകയാണ്. അങ്ങനെ കൊണ്ടുവന്ന ജനതയ്ക്ക് വിളിക്കുന്ന പേരാണ് ദി സ്റ്റോളൻ ജനറേഷൻസ്. നഷ്ടപ്പെട്ട തരത്തിൽ ചരിത്രവും വൈജ്ഞാനിക ലോകവും നഷ്ടപ്പെട്ട ഒരു ജനതയാണ് ഭാരതീയരും കേരളീയരും. മാത്തമാറ്റിക്സിനെ കുറിച്ച് തന്നെ പറയുമ്പോൾ ഗീർവർഗീസ് ജോസഫിന്റെ ദ ക്രെസ്റ്റ് ഓഫ് പീകോക്ക് വരുന്നതിന് മുമ്പ് എത്ര മലയാളികൾക്ക്, അക്കാഡമിഷ്യൻസിന്, മാത്തമാറ്റീഷ്യൻസിന് കേരള സ്കൂൾ ഓഫ് മാത്തമാറ്റിക്സ് അറിയാം എന്ന് ചോദിച്ചാൽ വളരെ ചുരുക്കം എന്നായിരിക്കും ഉത്തരം. 1996 കോഴിക്കോട് സർവകലാശാലയിൽ ഒരു MA ചരിത്ര വിദ്യാർത്ഥിയായിട്ട് ചെല്ലുമ്പോൾ അവിടെ ഗേൾസ് ഹോസ്റ്റലിന്റെ, ലേഡീസ് ഹോസ്റ്റലിന്റെ സമീപത്ത് ഒരു വലിയ ബിൽഡിംഗ് ഉണ്ട്. ഇത് എന്താണ് എന്ന് ആർക്കും അറിയില്ല. അപ്പോൾ അത് വാനനിരീക്ഷണശാലയാണ്. അന്നത്തെ പ്രൊവൈസ് ചാൻസലറായിരുന്ന ശശിധരൻ സാറ് പ്രത്യേക താല്പര്യമെടുത്ത് പണിത് ഉയർത്തുന്നതാണ് എന്ന് മനസ്സിലാക്കി. അതിന് മുന്നിൽ മാധവ മെമ്മോറിയൽ എന്നും എഴുതിയിട്ടുണ്ട്. ആരാണ് ഈ മാധവൻ എന്ന് അന്നും അറിയായിരുന്നില്ല. പിന്നീടാണ് 14ാം നൂറ്റാണ്ട് മുതൽ കേരളത്തിൽ ഒരു കേരള സ്കൂൾ ഓഫ് മാത്തമാറ്റിക്സ് ഉണ്ടായിരുന്നു എന്നും അതിൽ സംഗമ ഗ്രാമത്തിലെ മാധവനിൽ തുടങ്ങി അച്യുത പണിക്കർ, അച്യുത പിഷാരടി, നീലകണ്ഠ സ്വാമിയാജി, പരമേശ്വരൻ, മേൽപ്പത്തൂർ നാരായണ ഭട്ടതിരി, അതുപോലെ ജ്യേഷ്ഠദേവൻ തുടങ്ങിയിട്ടുള്ള ഒരു വലിയ സ്കൂൾ ഓഫ് മാത്തമാറ്റീഷ്യൻസ് പ്രവർത്തിച്ചിരുന്നു എന്നൊക്കെ മനസ്സിലാക്കുന്നത്. അപ്പോ കാൽക്കുലസിന്റെ അടിസ്ഥാന പ്രമാണങ്ങളൊക്കെ അവർ രൂപപ്പെടുത്തിയിരുന്നു എന്നുള്ളത് അത്ഭുതകരമായിരുന്നു. അതിന് തുടർച്ചയുണ്ടായില്ല എന്നുള്ളതാണ് നമ്മുടെ ഒരു സങ്കടം. അതുപോലെ നമ്മളുടെ കാലഗണനയെ കുറിച്ചുള്ള സങ്കല്പം വളരെ പ്രധാനപ്പെട്ടതാണ്. മലയാളികൾ വർഷത്തെ ആധാരമാക്കിയിട്ടാണ് കാലഗണന നടത്തിയിരുന്നത്. കാലവർഷം എന്നാണല്ലോ പറയുക. വർഷം വരുന്നതും പോകുന്നതിനെയും ആധാരമാക്കിയിട്ടാണ് നമ്മൾ അത് കണക്കാക്കിയിരുന്നത്. എന്നാൽ ഭാരതത്തിൽ പക്ഷേ ആയിട്ടാണ് കാലത്തെ ഗണിച്ചിരുന്നത്. നക്ഷത്ര ഗണിതം എന്നാണ് അതിനെ പറയുന്നത്. ഭാരതത്തിന്റെ പുരാതനമായ നക്ഷത്ര ഗണിത സമ്പ്രദായങ്ങളെല്ലാം തന്നെ നമുക്ക് നഷ്ടപ്പെട്ടു. അപ്പൊ അതില് ദ്വാപര ഗണിതമുണ്ട്, താരഗണിതമുണ്ട്, കലിയുഗ ഗണിതമുണ്ട്. അപ്പൊ ഓരോ ഗണിതവും വളരെ രസകരമായ രൂപത്തിലാണ് അവതരിപ്പിച്ചിട്ടുള്ളത്. ഇതറിയുന്ന ആളുകളും വളരെ കുറവാണ്. ഇപ്പോ രാമജന്മഭൂമി വിഷയം വളരെ സജീവമായി നിൽക്കുകയാണല്ലോ. ഇപ്പോൾ ക്ഷേത്ര നിർമ്മാണമൊക്കെ ആരംഭിക്കുകയുണ്ടായി. അപ്പൊ അതില് ദ്വാപര ഗണിതത്തിൽ പ്രഗത്ഭനായ പ്രൊഫസർ രാഘവൻ അദ്ദേഹം പറഞ്ഞത്, രാമക്ഷേത്രം പണിതിട്ട് കാര്യമൊന്നുമില്ല, കാരണം രാമന്റെ കാലം കഴിഞ്ഞിരിക്കുന്നു. കാരണം 1695 BC-യിലാണ് ദ്വാപര ഗണിത ചക്രം അനുസരിച്ച് ഭരണി നക്ഷത്രത്തിൽ സൂര്യൻ ഉദിക്കുന്നത്. ഭരണി നക്ഷത്രത്തിൽ ഉദിക്കുന്ന സൂര്യൻ വിഷ്ണു, ആ വിഷ്ണു രാമനായിട്ടാണ് അവതരിപ്പിക്കുന്നത്. അപ്പൊ അന്ന് മുതൽ രാമന്റെ ധർമ്മം ആരംഭിച്ചു. ഇവിടെ ഭരണി ദേവതയാണ് സീത, അതുകൊണ്ടാണ് രാമനും സീതയും ഒരുമിച്ച് വരുന്നത്. അപ്പൊ ഭരണി നക്ഷത്രം, അപ്പോ ആ ധർമ്മം 1695 ആരംഭിച്ചത് പിന്നീട് 1400 ആവുമ്പോൾ അവസാനിച്ചു. അപ്പൊ അതുകൊണ്ട് ഇനി രാമധർമ്മം ഉണ്ടാവില്ല എന്ന് അദ്ദേഹം പറയുകയുണ്ടായി. എന്തായാലും ഈ ഗണിതത്തിന്റെ സങ്കീർണത വളരെ പ്രധാനപ്പെട്ടതാണ്. അതുപോലെ സപ്തർഷി കുലത്തിലെ മാരീചികളുടെ ഗണിത പ്രകാരം 6000 BC-ക്ക് അടുപ്പിച്ച് മാരീചി കുലം ഇവിടെ നിന്ന് അത്രി കുലവുമായി പിരിഞ്ഞ് സൂര്യസിദ്ധാന്തത്തിന്റെ പേരിലുള്ള തർക്കമാണ്. ആ തർക്കത്തിൽ പിരിഞ്ഞ് സൈന്ധവ ദേശത്ത് നിന്ന് അവര് വോൾഗ തടത്തിലേക്ക് പോയതായിട്ട് പറയുന്നുണ്ട്. വോൾഗ തടത്തിൽ നിന്ന് പിന്നീട് അവർ തിരിച്ചു വരുന്നത് 2500 BC-യിലാണ്. അവിടെ മഞ്ഞുമൂടി വോൾഗ തടവും ഈ സ്റ്റെപ്പിയും തെക്കൻ റഷ്യൻ പ്രദേശങ്ങളൊക്കെ വലിയ മഞ്ഞുവീഴ്ച ഉണ്ടായപ്പോഴാണ് അവർ 2500 BC-യോട് അടുപ്പിച്ച് തിരിച്ചു വരുന്നത്. ഇത് പക്ഷേ ഈ ദ്വാപര ഗണിത ചക്രത്തിലെ ഗണനയിൽ ഇത് കൃത്യമായി കാണുന്നുണ്ട്. അപ്പോൾ 2500 BC കൂടി ആര്യന്മാർ ഇന്ത്യയിലേക്ക് വന്നു എന്ന് പറയുമ്പോൾ നമ്മുടെ പരമ്പരാഗതമായ പല പുരാണങ്ങളിലും അത് വിദേശത്ത് നിന്ന് ഇങ്ങോട്ട് വന്നവരായിട്ട് ഇന്ന് നമ്മൾ ആധുനികമായ രീതിയിൽ ചരിത്രത്തിൽ കാണുന്നതിനെ വ്യത്യസ്തമായ രൂപത്തിൽ കാണാൻ നമ്മളെ പ്രേരിപ്പിക്കുന്നുണ്ട്. ഇവിടുത്തെ മാരീചി കുലക്കാൾ 6000 BC അങ്ങോട്ട് പോയി 2500 BC ഇങ്ങോട്ട് വരുന്നു എന്ന് കാണിക്കുന്നുണ്ട്. ഇതിനെ ആര്യന്മാരുടെ വരവുമായി ബന്ധപ്പെടുത്താൻ സാധിക്കുമോ? അല്ലെങ്കിൽ ഈ ഗണിത ചക്രം ആധാരമാക്കി ഭാരതത്തിന്റെ ചരിത്രം എഴുതാൻ സാധിക്കുമോ? അല്ലെങ്കിൽ ധർമ്മചരിത്രം എഴുതാൻ സാധിക്കും? ധർമ്മം വരുന്നത് ഇങ്ങനെയാണ്. ഇപ്പോ കമ്മിങ് ആൻഡ് ഗോയിങ് ഓഫ് ഐഡിയാസ് ഡിറ്റർമൈൻസ് ദ കോഴ്സ് ഓഫ് ഹിസ്റ്ററി എന്നുള്ളതായിരുന്നു ഹെഗലിന്റെ ഒരു സങ്കല്പം. അപ്പൊ ധർമ്മചരിത്രം എന്ന് പറയുന്നത് ചില ആശയങ്ങളുടെ വരവും പോക്കും എങ്ങനെയാണ് പുതിയ ചരിത്ര ഘട്ടത്തെ നിർമ്മിക്കുന്നതെന്ന് സൂചിപ്പിക്കാൻ വേണ്ടിയിട്ടാണ്. അപ്പോ ഒരു ധർമ്മം സ്ഥാപിച്ചു എന്ന് പറഞ്ഞാൽ ഒരു ആശയവും അതിനെ ആധാരമാക്കിയുള്ള ഒരു വ്യവസ്ഥയും സ്ഥാപിച്ചു എന്നാണ് അർത്ഥം. വിപ്ലവം എന്ന് തന്നെയാണ് അർത്ഥം. 1917 കമ്മ്യൂണിസ്റ്റ് വിപ്ലവം എന്ന് പറഞ്ഞാൽ അതുവരെ നിലനിൽക്കുന്ന ആശയത്തെയും അതിനെ ആധാരമാക്കിയിട്ടുള്ള രാഷ്ട്രീയ സാമൂഹ്യ വ്യവസ്ഥയും തകർത്ത് പുതിയൊരു വ്യവസ്ഥ വന്നു എന്ന് തന്നെയാണ്. ഇങ്ങനെയുള്ള ഒരു ധർമ്മ സംസ്ഥാപനം, നമ്മളത് ക്രൂഡായിട്ട് പറയുകയാണെങ്കിൽ ഇവിടെ ധർമ്മ വ്യവസ്ഥ വരുന്നു എന്നർത്ഥം. ധർമ്മവ്യവസ്ഥയാണ് എല്ലാ സാമൂഹ്യ സാമ്പത്തിക രാഷ്ട്രീയ വ്യവസ്ഥയുടെയും അടിസ്ഥാനമായിട്ട് പ്രവർത്തിക്കുന്നത്. അത് സ്ഥാപിച്ചു എന്നാണ് അർത്ഥം. അപ്പൊ ഇതിന്റെ വരവും പോക്കും പലപ്പോഴും നക്ഷത്രങ്ങളുടെ ഗണനയും അതിന്റെ സ്ഥാനവുമായിട്ട് ബന്ധമുണ്ടായിരുന്നു, അഭിജാതനുമായി ബന്ധമുണ്ട്. അപ്പൊ ഇങ്ങനെയുള്ള ബന്ധങ്ങളെ ചരിത്രവും നമ്മുടെ സമകാലീന ജീവിതവുമായും ചേർത്ത് വെക്കാൻ പലപ്പോഴും നമുക്ക് കഴിഞ്ഞിട്ടില്ല. അപ്പോൾ ഇത്തരത്തിലുള്ള അന്വേഷണങ്ങൾ ഇനിയും നമുക്ക് നടത്താവുന്നതാണ്. നമ്മളുടെ മാത്തമാറ്റിക്സിലുള്ള അറിവിന്റെ അടിസ്ഥാനപരമായ അറിവുകളെ അതിനെ എങ്ങനെ സമകാലീന അറിവുകളുമായി ചേർത്ത് വെക്കണം. കാരണം വിജ്ഞാനത്തിന് ഒരു കണ്ടിന്യൂറ്റി ഉണ്ട്, അത് തുടർച്ചയിലാണ് നിൽക്കുന്നത്. നമ്മുടെ ചരിത്രപരമായ വിജ്ഞാനത്തിന്റെ ട്രഡീഷണൽ നോളജ് സിസ്റ്റം എന്ന് വേണമെങ്കിൽ പറയാം. ഈ ട്രഡീഷണൽ നോളജ് സിസ്റ്റത്തിന്റെ തുടർച്ചയിലാണ് നമുക്ക് ആധുനികമായ വിജ്ഞാനത്തിലെ എക്സലൻസ് ഉണ്ടാക്കാൻ സാധിക്കുകയുള്ളൂ. അതല്ലെങ്കിൽ അത് വെറുതെ പഠിച്ചു പോകാൻ പറ്റും എന്നുള്ളത് മാത്രമാണ്. അതുകൊണ്ടാണ് പണ്ട് സൂര്യസിദ്ധാന്തവും ബ്രഹ്മസിദ്ധാന്തവും കാലഗണനയും താരഗണിതവും ഒക്കെ ഉണ്ടാക്കിയ ഭാരതീയരിൽ എന്തുകൊണ്ട് ഇന്ന് നമ്മൾ ആസ്ട്രോണമിയുടെ രംഗത്ത് ഒരു കുതിച്ചുകയറ്റം, ഒരു വലിയ നേട്ടങ്ങൾ നമുക്ക് ഉണ്ടാക്കാൻ പറ്റുന്നില്ല എന്ന് പറഞ്ഞാൽ ആ കണ്ടിന്യൂറ്റിയിൽ നമ്മൾ ആധുനികവൽക്കരണത്തിലേക്ക് പോയില്ല എന്നുള്ളതാണ്. അപ്പോൾ ആ ധാരയിൽ ഇപ്പോൾ പ്രൊഫസർ ജോ ജേക്കബിനെ പോലുള്ള ആളുകൾ കടന്നു വരുന്നത് വളരെ സന്തോഷകരമാണ്. ഇതിനർത്ഥം എല്ലാം പണ്ടുണ്ടായിരുന്നു എന്ന് പറയുന്ന വിവരദോഷമല്ല, മറിച്ച് പണ്ടുണ്ടായിരുന്നതിന്റെ തുടർച്ചയിലാണ് നമ്മൾ നിൽക്കുന്നത്. വലിയ ജ്ഞാന വ്യവസ്ഥ പണ്ടുണ്ടായിരുന്നു, അതിനെ ആധുനികവൽക്കരിച്ച് ഉപയോഗിക്കുക എന്നുള്ളത് വളരെ പ്രധാനമാണ്. കണക്ക് മലയാളത്തിന് വഴങ്ങുമോ, അല്ലെങ്കിൽ മറ്റ് ആധുനിക സയൻസ് മലയാളം പോലെയുള്ള ഒരു ചെറിയ ഭാഷയ്ക്ക് വഴങ്ങുമോ എന്നൊക്കെയുള്ള ചർച്ചകൾ നടക്കുന്ന സമയത്ത് ജ്യേഷ്ഠദേവൻ യുക്തിഭാഷ രചിച്ചിരുന്നു എന്നത് നമ്മൾ മനസ്സിലാക്കണം. എത്ര മനോഹരമായ രചനയാണത്. അപ്പോ അദ്ദേഹം ഈ കേരള സ്കൂൾ ഓഫ് മാത്തമാറ്റിക്സിൽ പെട്ട ആളാണ്. അദ്ദേഹം യുക്തിഭാഷ എന്ന ഗ്രന്ഥം രചിച്ചിരുന്നു. അത് ഇപ്പോഴും നമുക്ക് പഠിക്കാൻ സാധിക്കുന്ന ഒന്നാണ്. ഈ രൂപത്തിൽ മാത്തമാറ്റിക്സിന്റെ വലിയ പാരമ്പര്യം മലയാളിക്കുണ്ട്, ഭാരതീയർക്കുണ്ട്. ഒരുപക്ഷെ ലോകത്തിന് തന്നെ മാർഗദർശിയാകാവുന്ന മഹത്തായ ജ്ഞാന പാരമ്പര്യത്തിന് ഉടമകളായിരുന്നു ഭാരതീയർ. അതുകൊണ്ടാണ് വിജ്ഞാനത്തിന്റെ ദിക്കായിട്ട് കിഴക്കനെയാണ് നമ്മൾ പലപ്പോഴും കാണുന്നത്. ക്രിസ്തു ജനിച്ച സമയത്ത് കിഴക്ക് ഒരു നക്ഷത്രം ഉദിക്കുകയുണ്ടായി എന്നും കിഴക്ക് നിന്ന് 3 പൂജാ രാജാക്കന്മാർ അദ്ദേഹത്തെ കാണാൻ വന്നുവെന്നും ഒക്കെ പറയുന്നുണ്ട്. അങ്ങനെ എന്നും വിജ്ഞാനികളുടെ ദേശമായിരുന്ന ഈ കിഴക്ക്, ഒരുപക്ഷെ ഭാരതവും ചൈനയും ഒക്കെ അടങ്ങുന്ന പ്രദേശം, നമ്മളുടെ ജ്ഞാന പാരമ്പര്യത്തിൽ നിന്ന് നമ്മൾ പിന്നോട്ട് പോയി എന്നുള്ളത് തീർച്ചയായിട്ടും സങ്കടകരമായ കാര്യമാണ്. അതുകൊണ്ട് പഴമയെ പഴമയുടെ രൂപത്തിൽ സ്വീകരിക്കുന്ന പുനരുത്ഥാനവാദമല്ല വേണ്ടത്. പഴമയിൽ ഉള്ള വിജ്ഞാനത്തെ എങ്ങനെ ആധുനിക വിജ്ഞാനവുമായി ഘടിപ്പിച്ച് കൂടുതൽ വിജ്ഞാന വിസ്ഫോടനം ഉണ്ടാക്കാൻ സാധിക്കുമോ എന്നാണ് ആലോചിക്കേണ്ടത്. നമ്മുടെ മലയാളത്തിലെ വളരെ പിന്നോക്കം നിൽക്കുന്ന ജനവിഭാഗങ്ങളിൽപ്പെട്ട ആളുകളുടെ ഇടയിലുള്ള ചില പാട്ടുകളാണ്. ആദിയില്ലല്ലോ ലന്തമില്ലല്ലോ എന്നുള്ള പാട്ട് നിങ്ങൾക്ക് എല്ലാവർക്കും അറിയാം. ആദിയില്ലല്ലോ ലന്തമില്ലല്ലോ കാലം പോല യുഗത്തിൽ, ആദിയില്ലല്ലോ ലന്തമില്ലല്ലോ കാലം പോല യുഗത്തിൽ. കുട്ടികൾക്കൊക്കെ അറിയാവുന്ന പാട്ടാണ്. അതില് ആദിയും അന്തവും ഇല്ലാത്തൊരു കാലത്തെ സങ്കല്പിക്കുന്നു, ഒച്ചയും ഓശയും ഇല്ലാത്തൊരു കാലത്തെ സങ്കല്പിക്കുന്നു, ഇരുളും വെളിച്ചവും ഇല്ലാത്തൊരു കാലത്തെ സങ്കല്പിക്കുന്നു. എന്നിട്ട് ആദ്യം വീണു പൊട്ടി മേലു ലോകം പൂകിയല്ലോ, ആദ്യമുട്ട വീണു പൊട്ടി കീഴു ലോകം പൂകിയല്ലോ എന്ന് പറയുന്നത് പുളുവൻ പാട്ടാണ് കേട്ടോ. അപ്പൊ അങ്ങനെ ഈ പ്രപഞ്ചത്തെ ഒരു മുട്ടയായി സങ്കല്പിക്കുകയും അത് പൊട്ടിത്തെറിച്ച് മേലെ ലോകമുണ്ടായി എന്നും കീഴെ ലോകമുണ്ടായി എന്നും പറഞ്ഞു വയ്ക്കുന്നു. ഒരുപക്ഷെ ഈ ബിഗ് ബാങ് തിയറിയോടൊക്കെ അടുത്ത് നിൽക്കുന്ന ഒരു പാട്ടാണെന്ന് ആശയമാണെന്ന് നമുക്ക് തോന്നും. ഏതായാലും ഈ അടിസ്ഥാന വർഗം എന്ന് പറയുന്ന വിജ്ഞാന പാരമ്പര്യവുമായി ബന്ധമില്ലാത്ത ആളുകളുടെ ഇടയിലുള്ള ഒരു പാട്ടിൽ ആദിയും അന്തവുമില്ലാത്ത ലോകത്തെ സങ്കല്പിക്കുന്നു, ഒച്ചയും ഓശയും ഇല്ലാത്ത ലോകത്തെ സങ്കല്പിക്കുന്നു, ഇരുളും വെളിച്ചവും ഇല്ലാത്ത ലോകത്തെ സങ്കല്പിക്കുന്നു. അങ്ങനെ സർവത്ര ശൂന്യത ഒരു സങ്കല്പമായി വരുന്നു. അവിടെ നിന്ന് പെട്ടെന്ന് മേലെ ലോകവും കീഴെ ലോകവും ഉണ്ടായതായിട്ട് പറഞ്ഞു വെക്കുന്നു. ഇത്തരത്തിൽ പ്രപഞ്ചത്തിൽ നിന്ന് ആരംഭിച്ച് നമ്മളിലേക്ക് വികസിക്കുന്ന ഒരു ചരിത്ര അനുഭവവും വൈജ്ഞാനിക അനുഭവവും നമുക്കുണ്ട്. അതിൻ്റെ അകത്തുനിന്ന് നമ്മൾ എത്രയോ കാലമായി, പ്രത്യേകിച്ച് കൊളോണിയൽ കാലഘട്ടത്തിൽ ആ വിജ്ഞാന വ്യവസ്ഥയിൽ നിന്ന് നമ്മൾ പറിച്ചെറിയപ്പെട്ട ഒരു ജനതയാണ്. അതുകൊണ്ട് ആ വേരുകൾ തിരിച്ചു പിടിക്കണം. ഇത്തരത്തിലുള്ള വെബിനാറുകൾ അത്യന്താധുനികമായ വിജ്ഞാന വ്യവസ്ഥയെക്കുറിച്ചും വലിയ നേട്ടങ്ങളെക്കുറിച്ചും ചർച്ച ചെയ്യുമ്പോൾ നമ്മൾ ചരിത്രത്തിലേക്ക് കൂടി എത്തി നിന്ന് ചരിത്രത്തിന്റെ തുടർച്ചയിൽ ഇതിനെ മനസ്സിലാക്കാൻ ശ്രമിച്ചാൽ അത് വലിയ നന്മയും ഗുണവും നമുക്ക് ചെയ്യും എന്ന് മാത്രം സൂചിപ്പിക്കുകയാണ്. ഈ വെബിനാർ സീരീസിലേക്ക് എന്നെ വിളിച്ചതിന് എല്ലാവർക്കും സ്നേഹപൂർവ്വം നന്ദി രേഖപ്പെടുത്തിക്കൊണ്ട് ഔപചാരികതയുടെ പേരിൽ ഈ വെബിനാർ സീരീസ് ഉദ്ഘാടനം ചെയ്തതായിട്ട് അറിയിക്കുന്നു. പ്രൊഫസർ ജോ ജേക്കബിന് എൻ്റെ ഹൃദ്യമായ അഭിനന്ദനങ്ങൾ സ്നേഹത്തിന്റെ ഭാഷയിൽ അർപ്പിക്കുകയാണ്. നന്ദി, നമസ്കാരം.
Thank you, sir. I also welcome Reverend Dr. Joy Painadas, Manager of St. Joseph College, Vice Principal Johnson Simeti, Assistant Manager Father Shijo Abraham. We are extremely grateful for your honorable presence. Next, I welcome Monsignor Clarence Palliet, Vicar General of Diocese of Kannur and former Principal of St. Joseph College, Latara, for felicitation.
Bishop Alex and Dr. P.J. Vincent, who inaugurated the session, Dr. Jacob, Professor Jacinta, Ms. Mekha, faculty members, participants from various parts of the world. I'm extremely happy to be part of this this program, this webinar. I think I must just take only 1 or 2 minutes because already running ahead. What is that? Short of the schedule now. As they say, when it is dark, men see the stars. All of us are certainly in the dark of the pandemic. And so it is important for us to see the stars. In fact, I was practically puzzled to see how mathematics and stars could go together. Because one is precision, the other is always the beyond. Of course, we have what is that? The give and take in this. Human beings have to be. We have to go beyond what we know, but we should be precise as much as possible. And so, my best wishes to the department. Of course, the department has been doing so well so far. I must really congratulate Professor Jacinta, the faculty members, students, and very especially this particular initiative of the department. And I'm sure this is going to be a very enriching experience for the department and for all the participants. My best congratulations to the department and my best wishes to everyone. Thank you very much.
Thank you, Monsignor. Now, I welcome Ms. Megha KP, Assistant Professor of Mathematics Department, for vote of thanks.
I deem it a great honor and privilege to propose the vote of thanks on our webinar, ASTERISK. First and foremost, I I thank Most Reverend Dr. Alex Vedakundala, Bishop, Diocese of Kannur, for his blessings and words of encouragement. His able guidance has always encouraged. I thank Your Excellency for your kindness, interest, and continued support. I'd like to propose word of thanks to Dr. P.J. Vincent Sir, Controller of the Examination, Kannur University, for gracing today's webinar and delivering the inaugural address. Thank you, sir, for your very interesting and thought-provoking address. I would like to thank our distinguished speaker, Dr. Joe Jacob, Head of the PG Department of Physics, Newman College, Thodupuzha, for accepting our invitation. I thank our principal, Dr. K.C. Muralidharan sir, for his support and presence. I would like to thank Reverend Father Clarence Pallier, Vicar General of Diocese of Kannur, and our former principal of St. Joseph's College, Pilatada, Father Reverend Dr. Joy Painadan, Manager of St. Joseph's College, Pilatada, our Vice Principal, Father Johnson Simeti, and Assistant Manager, Father Shijo Abraham, for their support, vision, and commitment. My heartfelt thanks to Professor Jacinta Luna, Head of the Department, for her moral support and guidance for this webinar. I owe gratitude to all other faculties of our department and students who have worked hard for this webinar. And last but not the least, I thank all other faculties from this college and students present here and inviting and accepting our invitation. Once again, thank you.
Thank you, ma'am. Moving on to the main section, I'm so glad to invite Dr. Joe Jacob, Head of PG Department, Physics, Newman College, Thodupuzha.
Dr. Joe Jacob obtained his PhD from Mahatma Gandhi University and did his postdoctoral studies in Cochin University. He has been working as a visiting associate of Inter-University Center for Astronomy and Astrophysics, IUCAA, Pune, since 2006 and is actively involved in research in astronomy and science popularization and education in the region. His research interests are in the fields of radio emission from galaxies and galaxy clusters, galaxy supercluster, structure formation, and microwave antenna. Dr. Joe Jacob collaborates with Professor Joydeep Baji of IUCAA and was a co-investigator in the Indo-French project on radio galaxies. He is a part of the discovery of superclusters, a megastructure of galaxies 4 billion light years away named Saraswati, which was widely reported in India and world media in 2017. He has made most 15 publications on astronomy and 33 publications on microwave electronics. He has been the coordinator of many technical seminars in different colleges in Kerala. He has attended several national and international seminars and also has presented papers at seminars conducted in South Africa, Thailand, IIA Bangalore, and NCRA Pune. He is a co-recipient of the 2018 New Discovery Award and the Zubin Kimbawe Award of the Astronomical Society of India. He is also the recipient of the 2018 Professor Shiva Prasad Best Teacher Award. Currently, he is a member of the Executive Committee of the ASI. Even during this pandemic situation, he has been a part of several webinars. We are extremely glad to have you as our resource person. Once again, we welcome you, sir, to our webinar.
Sir, please unmute yourself, Joe sir.
Sorry. I'm sorry. Thank you, sir. And warm good morning to all of you. And thanks to Sandra for introducing me. And I would like to convey my greetings to all the guests on the dais who spoke before me. His Excellency Bishop Dr. Alex, Professor Muralidharan, Dr. P.J. Vincent, the Controller of Examinations, and Monsignor Clarence, and Father Joy and Father Shijo. And greetings to also to teacher, Jacinda Luca teacher, head of the Department of Mathematics. So at the outset, I would like to thank the organizers of the webinar series Asterix for inviting me for such a webinar. Especially, I would like to thank Professor Jacinda Luca, who is a family friend of ours, for specifically inviting me for this webinar. So I'm very glad to be associated with St. Joseph's College Pilatura with regard to this webinar. And the topic of the webinar, Beyond Stars. I'm very happy that the subject is already introduced to you by the scholarly speeches by Professor Muralidharan as well as our Excellency, His Excellency, Dr. Alex, Bishop of the Diocese. And also Dr. Vincent was pointing towards connections between the historical facts and astronomy and many other facts. And I'm thankful to all of them for introducing the subject to the audience. And you may have a question in your mind, like the organizers of this department. Sorry, let me ask you whether I am audible and visible.
Audible, sir, audible, very much audible.
Okay, sir, thank you. So the question may be like, see, this is the Department of Mathematics at St. Joseph's College, Pilatura. Why should they conduct a webinar where a topic of physics is being discussed? So the answer to this question is epitomized in the saying that mathematics is the language of physics. Hopefully you students as well as all others who are listening to me might have heard about this. So this indicates that the physics can be expressed only through the language of mathematics. Mathematics is necessary for describing physics. You know that physics is something which describes the physical properties of materials. Now, without mathematics, if you say about physics, then it will be just a qualitative description. To go into the depths of what we understand about these physical properties, we need mathematics. So from earlier onwards, physics has been relying on mathematics. Mostly, I should say, from the time of Newton onwards, when he described all the motions in the on the surface of the earth, and in the from the period of Kepler onwards, where he was discussing all the motions in the skies. Mathematics was an essential part of physics. And you students may be studying various aspects of mathematics, say complex numbers and maybe matrices. So you may be wondering why I am studying all this without any meaning, but all the meaning mostly lies in physics. Because you know that maybe you may be familiar with the fact that all the equations which physicists deal with are mostly differential equations. Differential equations are treated in mathematics. So the basics come from mathematics. Matrix is used for the most modern, the modern subject of quantum mechanics. Mostly it is fully it deals with the matrices and connections. And the complex numbers, the negative numbers, imaginary numbers, etc., which seems to be abstract, is well used in electricity and magnetism in physics. So there is an intimate connection between physics as well as physics and mathematics. And and I should say that maybe mathematics is the breathing air for physics. Otherwise, physics may not be that much able to live. So coming to the connection between mathematics and astrophysics. The physics of the astrophysics is the physics of heavenly bodies. So you know that the measurements of the position of the stars or objects, as well as the dynamics, their motions, as well as the processes which are happening in them, all require mathematics. So this is why I presume that the Department of Mathematics has invited me for such a webinar, wherein maybe the students are able to get some idea about the mathematical connections of mathematics and other branches, mathematics and branches of physics. And since this is a sort of a basic lecture, you may not find I am working out some mathematics out of what I am telling, but mostly I'll be pointing to areas where mathematics will be heavily used. So with this introductory words, I would like to go to my slides and start the talk on the topic of beyond the stars. So let me present to you, and some of you can tell me whether I am visible from. So meanwhile, here I'm experiencing outside it is raining, and sometimes I'm not sure. Sometimes if there is a current failure, then I may be able to come back with a backing of a solar power within a few minutes. This is just a kind of initial kind of uh, some information. Okay. So is the slide visible to you?
No, sir, not yet.
Is it now visible?
No, no.
No. Okay. I
Okay.
need to use, maybe I didn't use the present button. Okay, share screen. Okay, I can do it now.
Okay.
I didn't share it. Okay.
Okay, coming.
Now possibly it will be.
Loaded, sir.
Yes.
Okay, sir.
Hope it is fine.
Yes, fine.
Okay. So
Yes.
let us go ahead. And the plan of the talk is this, and how much time, or maybe almost 1 hour may be available for me. You can stop me when the time comes, or maybe you can warn me before 10 minutes. So I'll be talking about giving a brief introduction of stars and what is beyond it. And then I'll be just discussing the efforts of scientists to go beyond the stars. That's a long story to discuss. The idea of something beyond the stars was also a very revolutionary idea earlier. And then I will go into the properties and classification of galaxies, which are structures beyond the stars. And then we'll discuss something about Milky Way galaxy and the group of galaxies. Then we go into galaxy superclusters, where I will be just discussing about our group's contribution to the astrophysics scenario. And finally, I will try to give you the large scale structure of the universe, how it looks like. So hopefully, if there is any disruption in my speech or a video or vision of the PPT, please inform me. So I'm starting with the first slide, where you can see a picture of the starry sky. This is a picture of a starry sky. You know that a starry night like this is usually termed as a romantic backdrop. But for the curious or for the scientifically bent people, there is a lot more to ponder about on it. The first systematic scientific theory explaining the observed night sky came in the form of the geocentric model of the universe. So this was mentioned to you by our earlier speakers, particularly if I remember correctly, Dr. Vincent was referring to these ideas, the earlier ideas regarding the model of the universe, and he was mentioning to the fact that India was far ahead earlier, and he was calling upon all of us to come to more recent knowledge, or India should grow itself into the recent knowledge in the field. And even though this theory of the geocentric model of the universe is not exactly correct nowadays, but it was a great theory at that time, because before that there were no scientific theories which were discussing about the structure of the universe. And I'm just trying to discuss the earlier theories, earlier models of the sky, which see usually they were terming it as a model of the universe. The reason is because at that time the sky was the universe. Whatever visible to the visible on sky was the whole universe for people, because they had only their eye to visualize the heavens or the celestial bodies. So whatever is seen in their eye was the universe for them. So in the course of progression of this lecture, I will tell you how this notion about a limited universe expanded beyond the sky, and it went into whatever many things which are not visible to the eye. So this story we will discuss in the forthcoming slides. So let me explain the geocentric model of the universe. Most of you might have been aware of this, and this model was discussed by none other than Claudius Ptolemy. I hope you are able to see this um, picture over here of
Yes.
Ptolemy.
Yes.
And he wrote a book, the Almagest. It was in the first century AD, and in this book he collected all the knowledge which was there in the scenario, or all the knowledge from earlier philosophers like Aristotle, and consolidated everything into this book. And then that book was describing the geocentric model of the universe. In this next slide, we will describe it a little more. His geocentric model of the universe was almost universally accepted until the appearance of a simpler heliocentric model. This happened many centuries after, in the 16th century. And this model of heliocentric model of the universe was brought by Copernicus. This is Nikolai Copernicus. He was a priest. And His Excellency was referring to the number of priests, or the role played by priests in development of astronomy. You will also come across many crucial contributions given into the scenario by other priests also. So this Copernicus was responsible for the heliocentric model of the universe, but this was against the norm at the time. Everybody believed in geocentric model of the universe. So Copernicus was a little afraid to publish his ideas. So he did publish. He was reluctant to publish, in fact, but one of his assistants, he was very keen to. If I remember correctly, his name is Rheticus. And Rheticus took steps to publish this book, and the book is titled On the Revolutions of the Celestial Spheres. This was just before his death, just before Copernicus' death in 1543. So this idea were not taken up that seriously by people, but only later on, I will come to that story, when Galileo did visualize, or did look at the sky and found some of the evidences in favor of this heliocentric model of the universe, that this heliocentric model did replace the geocentric model. The reason is because the geocentric model was so rooted in the minds of people, and was highly accepted by the religious authorities, because this the geocentric model also has got some there is some place for God in the model. So that is the reason why the religion, the prevalent religion in Europe, Christianity, was supporting this geocentric model. Now, coming to the next slide, I am just showing a view graph of what the geocentric model, or the Ptolemaic model of the universe is like. So you can see that in this model, the Earth is assumed to be at the center. So this is just a commonplace knowledge. Like when you are viewing from the Earth, we see that the Moon, Mercury, Venus, as well as the Sun, Mars, Jupiter, Saturn, all are moving in the sky. So this model, as seen from the Earth, was depicted in the Ptolemaic or geocentric model. So we know that we are seeing that the sun is, we are observing that the sun is moving across the skies because of the reason that we are moving around the sun, not because the sun is moving around us. But at that time, people thought that the sun was moving around the earth. So earth was thought to be central. And then during that time, human beings were given some very special status. So it was always good to think that human beings are the center of the universe, and the earth is the center of the universe. So that is why that idea was so much prevalent. And this is the model. And you see only up to Saturn here. You might ask why all the other planets are left out. The reason is because beyond Saturn, people were not able to visualize using the eye. Those planets were discovered during the time of telescopes. So earlier this was not seen because they are very far away, they can't be seen. But people could visualize till Saturn. So until Saturn, all these were in the geocentric model, and the stars were thought to be on a sphere, situated on a sphere which is most farthest, like this. And all these circular paths were assumed to be assumed to be followed by these heavenly objects. And then these circular paths are followed by these heavenly objects, but they could not imagine how these heavenly objects are there without any support. So they were thinking that all these circular paths were part of a sphere. You can imagine concentric spheres around Earth, and these paths, these planets were fixed to that spheres, and the spheres are moving. All these spheres are connected and they are moving, and ultimately there is a outermost sphere which is called the prime mover, which is where the God's hand comes in, where he is putting in all the motions. That was the thought. So this is a two-dimensional view. Actually, they assume that surrounding there is a sphere, and on that sphere this moon is fixed, and moon is moving around a circle like this when the sphere moves. So this is the idea. And then there was a problem that some of the planets were also seen to be having having
Sir, you are not heard, sir. Not audible. Joe, sir. Hello. Hello, sir. Joe, sir. സാറ് നേരത്തെ പറഞ്ഞിരുന്നു സോളാറിന്റെ
സർ അദ്ദേഹം ലെഫ്റ്റ് ആയിക്കൊണ്ടിരിക്കുന്നു.
അല്ല വരും തിരിച്ചു വരും പറഞ്ഞിരുന്നു, നേരത്തെ പറഞ്ഞിരുന്നല്ലോ. കാരണം സോളാറാണ് കറണ്ട് പോയാൽ ഉപയോഗിക്കുക, അപ്പൊ സോളാറിന് കുറച്ച് സമയം എടുക്കും എന്നാ പറഞ്ഞത്. വരും. നേരത്തെ he has given us a caution about this.
കോള് പോലും പോകുന്നില്ല സർ.
ഇല്ല. വരും എന്ന് പറഞ്ഞിട്ടുണ്ട്.
അല്ലല്ല, കോള് പോലും പോകുന്നില്ല എന്ന് പറയാം, റേഞ്ച് കിട്ടുന്നില്ല.
വരും അതിന്റെ കണക്ഷന്റെ പ്രശ്നമായിരിക്കും. അത് സോളാർ ഒന്ന് ആയി വരണം എന്ന് പറഞ്ഞു, ഒരു തിരിച്ചു വരും എന്ന് പറഞ്ഞിട്ടുണ്ടായിരുന്നു.
കണക്ഷൻ പോയി അല്ലേ, കറണ്ട് പോയി അല്ലേ?
Sorry, there was a power disruption. And maybe I have to, because it is raining heavily outside here. So I have a solar power. I hope that it will sustain the lecture. Anyway, let me project the screen again.
Multiple
things.
Windows are there, sir.
Okay, I need to close it maybe again.
Yeah.
Oh my goodness. There's some problem. I don't know. Seems to be some problem. Um, Screen sharing, maybe I can close this. So it seems my host disabled attendee screen sharing. So maybe I have to be enabled.
Oh. And Amiga? And Amiga?
Lenish.
Ah.
ചെയ്തിട്ടുണ്ട് മിസ് കോഹോസ്റ്റ് ചെയ്തിട്ടുണ്ട്.
Okay, okay.
There is some issues.
I think it's not working, sir. It's not working.
So I'm trying to share the screen.
Yeah. Yes. Yes. We see you.
Same problem.
Yes, it's coming.
No. Maybe once again I can get out and join again.
Okay, sir. Okay, sir.
Is it okay now?
Yes, sir. Yes, sir. Yes, sir. Visible, visible. It's visible, sir.
Is it okay?
Okay, okay, sir. Fine.
All right. So we will continue. So I'm getting a reflection. Maybe some of the mics may be on. Can the organizers please check? Hello.
Hello, sir. It's visible, sir. Visible. Slide is visible.
Two screens. Is it okay now?
Yeah.
Okay, so I think there were two windows open. So one was reflecting the
Yeah.
other.
Yeah.
So let me go ahead.
Yes,
And
sir.
this is, I was talking to, I'm sorry for the disruption. I was talking to you regarding the geocentric model of the universe, which was replaced by the heliocentric model of the universe. And in the geocentric model, there is this concept of epicycles. So it was assumed that this circular orbit itself has got another circle on it, and on which these planets are revolving. This is in order to explain the change in the brightness of the objects as time goes. So these all models were found to be explaining whatever observation they were having at the time, but the model was wrong. That's the only the reason which we find later on. And then in 16th century, I have mentioned to you that Copernicus did bring in the new model where the sun was at the center, and all these were revolving around the sun. And during that time also, until Saturn, the planets until Saturn were known. Then there was all the stars were assumed to be on a particular sphere which is covering, which is beyond all these planets. And there was nothing known beyond the stars. So all the stars were assumed to be on a sphere which is studded on a sphere like this. This is the last sphere, and there is some prime mover or something. And this is a Copernicus model. And then the sun was at the time sun was taken as the center of the universe. I should put universe in a bracket, because at that time the universe meant only solar system and the connected objects. And this heliocentric model was ironically, it was earlier suggested by Aristarchus of Samos in 2nd century BC even. But nobody did believe him at that time. But at the time of Copernicus, then also people didn't believe him, but they had to believe him. This is something else which may not require the representation here. They had to believe, since Galileo did bring in some of the evidences in favor of Copernicus model. So by going chronologically, I would also like to mention to you regarding the Kepler's laws. Johannes Kepler was assistant to Tycho Brahe, who was a well-known astronomer at that time in Europe. And he was very wealthy also. He had all the facilities for observing the skies, and he was continuously observing the sky and taking measurements of the sky, and he had all these tools for that. Obviously, I can refer here also to mathematics. He will be using the principles of trigonometry in order to find the position of the stars, and to pinpoint them where they are and what their properties are. And then he was more interested, rather than stars, he was more interested in planets. So he was studying the motion of the planets, and he had a volume of data with him. But he was a kind of a very strict person, and Kepler was not having access to many of his data. Kepler was in fact more brilliant than Tycho Brahe. Tycho Brahe was very eminent in taking readings and all, but interpretation Kepler was very good. But he was not getting the data. But fortunately for him, maybe Tycho Brahe died at an earlier age, and all these data were lying there. And all the Tycho Brahe I mentioned to you was a very wealthy person, and all his relatives took all his wealth, and they were on to discard all his papers, and they told Johannes Kepler, okay, you dispose of all these papers and all. He was the happiest man on the earth at that time, because he knew the value of that papers. And the rest of the life of Johannes Kepler was on working on all the data which was taken by Tycho Brahe, which resulted in all these three laws, which will be much familiar to everybody listening to me, I'm quite sure, because this is a topic in the school classes. So he is the first person who made a paradigm shift in describing the orbits of the planets, and he told that the planets may not be circular; it can be elliptical. This was a um, this was against the norm which was put by Aristotle and the Greek philosophers, saying that the circle is a perfect mathematical square. So, sorry, mathematical curve. So since God created everything, he will create everything perfect, and therefore all the planets which he created should go around a circle. So this has got a mathematical connotation. That's why I'm mentioning this. So Aristotle was of the view that sphere is a perfect shape, as well as a circle is a perfect kind of a curve. So all the heavenly bodies should be spherical, and it should go around a circular orbit. So Aristotle, whatever he told at that time, many of the things were disproved later on. You know the story and all about the Galileo's experiments on the Tower of Pisa, etc. So many things. Out of this norm was also changed, or it was also corrected by Kepler, that the planet is moving around an ellipse. So when Kepler did mention that or find out that the planet is moving around the sun in an elliptical path with the sun at one of its foci, then everything was easy for him to explain. Then he also made this equal areas second law, where he says that when the planet is nearer, it will be moving faster, and when it's farther, it will be moving slower. All these things are even intact today. And he also found a relationship between the time taken by this planet to complete one revolution to the semi-major axis. So many of you are mathematics students. No need to explain to you what a semi-major axis means. So t square is proportional to a cube. It is third law, and all these three laws were the whole life of Kepler. So the third law itself took more than 10 years for him to formulate. Okay, this was a major milestone, and all these laws are holding good even now. And on the course of this lecture, we will also come to understand wherever the other places these Kepler's laws are applicable. Okay, so I am coming to what Galileo's contributions were. He is the first person to use instrument to view the sky. So I told you that the perception of the skies was limited to the power of the eye. So Galileo, normally people think that Galileo discovered or invented the telescope. That is not right. This telescope was invented by somebody by name Hans Lippershey or so, who is an optician at that time. And Galileo did happen to see this telescope for sale in market, and he bought one of them. And nobody did think that this telescope could be used to view the skies. But Galileo, being an astronomer, he was very happy to have this telescope, and he used it for looking at the sky. And this telescope was very small. It was some 3 centimeters or so in diameter. But even with this small telescope, he was able to see wonders from the sky, which was not perceivable by eye. He did visualize new things, many new things, and that landed him in trouble, since he is seeing new things which are not seen by by our eyes. Then the authorities at that time, or maybe the religious people, religion at that time, was thinking that Galileo is seeing all this because of the influence of devil. And then he had a little difficulty in his life, and he was imprisoned. Home arrest was there, etc. And those are all connected with the societal norms. At that time, the society was very adamant on geocentric model of the universe, and the Galileo's some of the observations were against the conventional norms. That's why people were against him mostly. So this is the telescope which he used. This is now displayed in this museum. And Galileo's observations were capable of adding much to what was observed through naked eyes. And let us see what Galileo did add up to the body of knowledge. So the moon was observed to be a very perfect sphere, because the reason is because according to Aristotle, everything created by heaven should be perfect. But when he looked at the moon, when Galileo looked at the moon, he found this image like this. It had some certain crevices over there and some hills over here, and it was not at all smooth. So this is some new idea which he obtained from his telescope. Then he found the moons of Jupiter. Galileo, the Jupiter is a planet, and looking by eye, we may not see any of its satellites, but he could see the moons of Jupiter, or the satellites of Jupiter: Io, Europa, Ganymede, and Callisto. There is another view graph where I will show you further about this. Then he saw the Venus has phases, like the like the waxing and waning of the moon, the Venus also had phases. And this observation has a profound influence on the knowledge of at the times. And this was supporting the Copernicus view of the universe. And we will come to that. And then Galileo observed sunspots. He found that the sun had spots on it. And these spots are moving. And he found that the sun is rotating. And it was a period of somewhat like 27 days. And because of this, you know that it's not harmful to look at the sun. And even use with a telescope, if he is looking continuously, then he might harm his eyes. And this happened. Galileo became blind because he looked at the sun at the later part of his life. And then he also visualized the appendages of Saturn. Saturn was just seen as a round object by people by naked eye. But Galileo, when he observed, he found that there was some ear-like appendages for the Saturn. And he didn't knew that it is the rings of Saturn. Only later on that people found, using a larger telescope, that they should see that there are rings around Saturn. And then the most important thing may be that he resolved the Milky Way. See, when people look at the sky, they see a patch of light across the sky, or a brighter portion of the sky, and people were not knowing what it was, and it was called Milky Way since it is white in color. It was visible on the sky in an angle every day when the sky is clear. This white patch of light is actually our own galaxy, which contains a lot of stars. And this white patch is having all the stars close by. We also see other stars which are not at the center of at the disk of the galaxy. Those individual stars are there, which we also see. That's a part of Milky Way. And the central portions of the Milky Way is this kind of a patchy portion in the sky. And when he looked at this patchy portion, he found using his telescope that this patchy portion or white portion contained very closely spaced stars. So that is why he is the first person to understand that the Milky Way contained stars, which are Milky Way, which we see in the sky, contained stars which are very closely packed. So this is his own handwriting. And here you can see he has depicted the Jupiter by this, and all the 4 stars are depicted on various days on his various diagrams here. This is a letter he sent to Leonardo Donato, some Doge of Venice in 1609. And okay, yeah, I must, sorry. Yeah. And these are the sunspots which Galileo observed. This is his own illustration of the sunspots. This is a letter which he sent regarding the moons of Jupiter. I just wanted to show you some of the historical documents, that's all. So this thing, the Jupiter's moons were observed in 7th of January 1610, and the sunspots in 1612 using his telescope. Okay. Now, I just wanted to tell you how Galileo was able to prove that the Copernicus model was right by looking at the Venus and seeing its waxing and waning, or its phases of Venus. So if the geocentric model is correct, then the Earth is here, and the Venus is here, and the Sun is beyond Venus, and the Venus also is traveling through an epicycle I mentioned to you earlier, like this. So if this is the case, since the Sun is here when the Venus is here, the Sun is showing in the back side, and by looking at the Earth, we will see the dark side of the Venus, and we should see it as dark. So when the Venus is far away, then we should see it as dark as well as small. But originally, when Galileo viewed Venus, he found that when Venus is seen as small means it is far away from Earth, then it was found to be full, like it is fully illuminated. This could be only explained if only the Sun is at the center, and the Venus and the Earth are revolving around the Sun, and the Venus should be also revolving around the Sun inner to the Earth. Then only this process can happen, because Sun is here, which directly shines here. We look from here, we can see the Venus as a completely bright. And also when the Venus moves across, its various phases were seen. So this was a very solid proof for the Copernican model. These are some of the reasons why Galileo was persecuted at that time. So he was going against the norms. But he was very clever. He was writing all his books in a very compliant way, like some conversation taking place between various other people. It is not, like he is not telling this, but somebody else is discussing these matters and all. He wanted to convey the scientific ideas in a very clever way by writing books like this. So those who are interested about Galileo, there are tons of maybe much of information in the net. It is very interesting to read how he how his observations were instrumental in bringing in new knowledge to the to astrophysics or astronomy. Okay, so I am just mentioning another milestone in the development of astronomy, and this is nothing but the Newton's law of gravitation. You are all familiar with the Newton's law of gravitation, so I may not say anything about this. Just that if there are two bodies of masses m1 and m2, they are attracted with each other. And I should mention here that this is this Newton's law of gravitation which is responsible for all the structure formation in the universe. Our Earth is held together because of the Newton's law of attraction between the portions of the Earth, and the Sun is held together. Even though Sun is gas, it is held together because of a law of gravitation. And all the sun-like stars, almost 200 billion of them, are held together in our galaxy because of this law of gravitation. So the whole universe, whole of the universe is existing because of the law of gravitation. So beyond Newton, it existed, but nobody knew that it is there. And it was Newton who told us that the law of gravitation is true in the case of the universe. And this is very important milestone in understanding the universe. Now I'm just going by chronology that at the time I mentioned to you that most of the universe to the people were the solar system objects plus some stars which are in the sky. Rather than stars, people were also able to visualize some of the fuzzy objects which are comets, which just appear and go, which are called comets. You know what comets are. And it was a fashion thing for the scientists to hunt for comets and discover or invent two new comets and put their name to the comet. So you know that the comet may appear and it may come only after some 80 or 90 or 100 years. So if it appears, and if you are a scientist at that period of time and you spotted it first, then your name can be put on the comet. And a lot of people were hunting for comets. And there was a problem for these comet hunters, that there were also non-comet objects which mimicked like comets, which are some fuzzy objects which were seen in the sky when they are looking through the telescopes. This all the comet hunting was happening through the telescopes. So I'm telling after Galileo, after many years after Galileo, more and more larger telescopes were made by people, and they started seeing all these comets as well as some other fuzzy objects in the sky. And these fuzzy objects which looked like some spiral kind of some spiral kind of object, some luminosity over there. It looks different from stars, but people were not knowing what it was like. So they were calling it as a nebulae. And this gentleman, Charles Messier, he wanted to help these comet hunters, and he actually spotted all the nebulae which were on the sky, and then he made a catalog of these nebulae. And he was not knowing that what he was doing unknowingly was to catalog some of the other galaxies than our galaxy. So at that time, people were never knowing about galaxies. They didn't knew that something existed beyond our visualization of stars and the planets. So he was just making a catalog, and they compiled a catalog to guide the comet explorers. And this catalog was presented in the French Academy of Sciences. And there were initially 103 objects, and after all, later on, it was updated to some 110 objects. And see, the first object which is spotted is M1, Messier 1. This happened later on to be an exploding star. It is not a galaxy, but it is the envelope of an exploding star. This is only known later. I'm just connecting his catalog objects to what we know today about it. So this was that. But M104 is a full-fledged galaxy, which is known to now as a Sombrio galaxy. But he, using his telescope, this was seen as a very small patchy object in the sky, not so big as this. So then he put it as a nebulae. But this nebulae turned out to be a galaxy later on. So likewise, many of the Messier objects, M1 until M110 is there, because 110 objects were there. Many of them turned out to be galaxies which are outside our galaxy. Now, going ahead, we should discuss about William Herschel. He was the person who discovered Uranus using his telescope. This is his telescope. And the other major contribution by him is the making a catalog of 1,000 new nebulae and cluster of stars. So stars sometimes existed as clusters nearby, many stars nearby. So all those clusters of stars in the sky, as well as new nebulae, all those were catalogued by him. And the major contribution is that he tried to map the Milky Way. So I told you that Milky Way is some sort of a patchy portion in the sky, which Galileo did see as a contained stars. Then this gentleman with his larger 40 feet telescope, you can see how high it is, how big it is. He spotted each and every star and made a kind of a map of the Milky Way. This nothing nowhere resembles the actual map of the Milky Way, but this as an initial trial, this is to be commended. And a lot of stars he could position, and he made this map, and sun was placed at the center. This was not right, but later on somebody else corrected it, and the perception just expands. Our perception just expands depending upon larger and larger telescopes which were in use by scientists. So I am just telling that story of expansion of our perception. Initially, the models of the universe were just pertaining to the solar system. Then it went on to the Milky Way, and people were able to spot the stars in the Milky Way. Then later on, next idea will be like by this scientist, Harlow Shapley, American astronomer. He did say that the sun is not at the center of the universe. He studied some star clusters by name globular star clusters, and globular star clusters should be equally spaced. Many star clusters, if they are there, then they will be equally spaced around the center of the galaxy. He found that if the sun is at the center, then there should be equal number of globular clusters in the other in various directions from the sun, but he didn't see. So he said that he concluded that sun is not at the center of the galaxy, because when he studied globular cluster stars, this was in 1917. And very important, another contribution, or I should say my major milestone, was by this lady, astronomer. At the time, the ladies were not at all in science, but there were a few people who did their contributions by fighting against the odds. They became scientists, and this Henrietta Leavitt was an American astronomer who did bring in a very, very important aspect of the measuring the distances. See, if you are looking at the sky, we will see that everything on the sky is at a particular distance to us, and it is studded to some sort of a sphere above us. What we see is not correct. See, we have a stereoscopic vision. Our eyes have stereoscopic vision in near distances. We can see the depth in near distances, but it goes to far away vision. We lack that stereoscopic vision. So even if objects are at various distances, we say them, we cannot distinguish the distances. That is why all these objects in the sky, all the stars are seen to be at the equidistant from us. But in fact, it is not like that. It is because of the lack of stereoscopic vision at longer distances that we are not able to see this. So then Henrietta Leavitt understood that these stars are at various distances, and she wanted to calculate the distance to the stars. For that, what she used was, she selected some particular star by the name Cepheid variable stars. The luminosity of that star varies, and she could find a period luminosity relation. If that star is becoming brighter and lessens its brightness and again becomes brighter within 2 or 3 days, then she could find a relationship between this period of 2 or 3 days. If suppose it's 2 days, then 2 days and its luminosity. Likewise, she studied various Cepheid variable stars, and she could bring in a period luminosity relation. And I'm not going into the details, but she was able to decipher the distances to the stars using this Cepheid variable method. And eventually this became the key of measuring distance to galaxies. We will come to that. If we can see an external galaxy to the Milky Way galaxy and spot an Cepheid variable there, then that Cepheid variable can be studied according to this Leavitt's principle of and its period luminosity relation can be applied there, and the distance to that star can be found out. If that star is in a galaxy outside our galaxy, then we are actually finding the distance to that galaxy. I am coming to that in the coming slides. We will discuss that. Okay, so we are going ahead. Then I should discuss about the beginning of a great idea that there can be objects, or there can be objects outside our Milky Way galaxy. There can be galaxies outside our Milky Way galaxy. So His Excellency was mentioning to Immanuel Kant, and I think he is the first person who had this idea that there can be external objects to our galaxy. I'm not sure, maybe from my memory I'm telling it. And this was proved, or this idea had took the form of a very famous debate in science. which is called the Great Shapley-Curtis debate. This happened a century ago. This was happening, I'm mentioning that date, etc. A century ago, between this Harlow Shapley, this is the same Shapley whom I showed here. He is this photograph at his young age, and this is when he's older. So Harlow Shapley with Curtis. So Curtis was an American astronomer, and he is very senior to him. And this Curtis was of the opinion that the some of the spiral-shaped nebulae, which are seen as if it is a part of our galaxy or our solar system, this is actually objects which are outside our galaxy. But Harlow Shapley was favoring the idea that the whole universe is our galaxy, and those patchy objects which are seen are also a part of our galaxy. So there was a kind of an arranged debate between these two people, and this happened at 8:15 p.m. on F-26 for 1920. This year is the 100th year or centenary of the great debate, and April 26 it was 100th year of this centenary. So it focused on a lingering uncertainty about the extent of our Milky Way and whether it constituted the entire universe or just one of many island universes. I mentioned to you this. So Curtis was supporting the idea that Curtis argued that there were other independent galaxies, implying that they are exceedingly large and distant. All these nebulae-like things were very at large distances, and they are individual galaxies. But Shapley believed that the distant spiral nebulae were a part of our galaxy, to which the solar system belongs. And they published papers, etc. And this debate was not kind of having a culmination. Both presented their ideas, and nobody did know what was right and what was wrong. And what was right and what was wrong was proved by another person by name Edwin Hubble by a great discovery. This is Edwin Hubble. Edwin Hubble is a very famous astronomer who did make much of contributions to the scenario of astronomy and astrophysics. There is a telescope by name, a space telescope by name. Most of you may be knowing Edwin Hubble Space Telescope. And this year is also special to Hubble Space Telescope because of the reason that Hubble Space Telescope completes 30 years in its orbit around the Earth, visualizing the various fantastic views of the universe, various parts of the universe through its excellent images. That is completing 30 years now. So that was launched 30 years back by NASA and ESA by the space shuttle. Space shuttle is used for launching it, and then it continued revolving around the Earth and making observations of the sky. Why is space telescopes required? Because if space telescopes are above the Earth's atmosphere, and therefore they are capable of seeing the universe, objects in the universe, without the aberrations of the atmosphere. So that is the great importance of space telescopes. So the first ever space telescope and the most efficient space telescope may be the Edwin Hubble's name, that is the Hubble Space Telescope. So you can type in the web in the net like 30 years of Hubble Space Telescope, and you will get a lot of information regarding very interesting information regarding the Hubble Space Telescope, how it was launched, and initially how the Hubble Space Telescope was not functioning well, and how it was repaired in space by astronauts, and how then astronomers started the practice of servicing this particular Hubble Space Telescope by going to space and removing some of the parts of the Hubble Space Telescope and again putting another parts, etc. And these are all called service missions of a Hubble Space Telescope. This I am giving you an additional information, and this is not in my PPT, but I am telling that this Hubble Space Telescope is named after this very famous astronomer Edwin Hubble, and this is his historic telescope by which he proved beyond doubt that there are galaxies outside our galaxy. And for that, what he did is he looked at the Andromeda Nebula. See, not this name Nebula. This was at that time not qualified as a galaxy. So it is called a nebula. This is M31, the 31st object in Messier's object. And he studied it. And he took photograph. This is a photographic plate which was used by him, on which this Andromeda Nebula was imaged. And he got this Andromeda Nebula like this. You may not be able to visualize here. This actually this nebula extends up to this. And then he spotted a variable star over here, like the Cepheid variable star. Then what he did is he he determined the distance to this variable star. This variable star is a part of Andromeda galaxy, and then he could get the distance. And then when he obtained the distance, then this distance was larger than the extent of Milky Way galaxy. What does that mean? If the distance to this object is larger than the extent of Milky Way galaxy, then this object should be outside the Milky Way galaxy. Then he postulated that this Andromeda nebulae is actually Andromeda galaxy, which is like a Milky Way galaxy. So he is the first person to prove that the Andromeda galaxy is another separate galaxy. And from then onwards, a new branch of astrophysics starts, which is called extragalactic astronomy or galactic astronomy. Not extragalactic, but galactic astronomy. Galactic means it can be pertaining to the Milky Way galaxy, but extragalactic means it is outside, about other galaxies. So he is actually the star who started this study of galaxies outside the Milky Way galaxy. Okay, so I think the thing is, so what is given here is the image may not be much pretty, but it opened the door for the first time in humanity to gaze into the vast universe. Thus, this image, this is the original photographic plate, which was used by Edwin Hubble, and this is his handwriting. Okay, he has written some date also here. Okay, fine. So I mentioned about him. He is using this telescope, adjusting this telescope, and this is the big telescope at the time. And he was using Mount Wilson 100-inch telescope in 1922. And this has a speciality. This is the largest refracting telescope. This is even now kept, even if it is not used for observations. So these used lenses in it. So the practice of using lenses is now in the large telescope, it is not there because lenses become very heavy. But this has a very heavy lens over here, which is focusing all the light which is coming in. So this is the 100-inch is the 100-inch Mount Wilson telescope is the largest refracting telescope existing. Now this proved that the Curtis argument is true. He gave the idea that there are external galaxies. And he also measured the distance to NGC 6822, and again he found the distance as a 2 million light years, etc. So they measured the distance to so-called spiral nebulae and extended all the extended objects seen in the night sky were considered as nebulae within our galaxy. But he found that many of these nebulae are actually galaxies outside our galaxy. Then there is also another important contribution by him. So the Hubble was Hubble, he brought in the Hubble law, V is equal to h0d. This means that he studied many galaxies and he measured the distances to the many galaxies and the velocities of recession of these galaxies. All these galaxies, he found that they are all moving away from us. And these distances were obtained by using this Henrietta-Lewis method, and the velocity of movement of these objects away from us was obtained by his assistant Milton Humanson by using spectral lines. And then he had this law, which is called Hubble law. V is equal to h0d. Means if the distance is larger, then the galaxies will also be moving away from us in a larger speed. So he found that most of these galaxies are moving away from us. That means all the galaxies are moving away from us means that the universe is expanding. So the expansion of the universe, this idea was brought in by Hubble, Edwin Hubble. He found that there are galaxies outside our galaxy and all these galaxies are moving away from us and the universe is expanding. So this Hubble law is giving us an idea that the universe is expanding. I'm just skipping this slide. This concerns redshift and blueshift. He was found that the spectrum obtained from all these galaxies where most of them are redshifted. That means redshifting means they are moving away from us. I am not getting time to explain it to you. So this Hubble law was stated by plotting distance along this direction and velocity of recession along this direction, and he found a straight line because V is proportional to D. I don't need to mention to you, mathematics students, how these graphs are drawn, etc. It is not at all required. So this is a sort of a relationship between velocity of recession and the distance. And this is the starting point of cosmology. Cosmology is a subtopic of astronomy studying the origin and evolution of the universe. This simple law is the cornerstone of all the cosmological developments. So, and the beginning of observational cosmology. Cosmology is the study of the origin and evolution of the universe. I will not be discussing cosmology, but just wanted to mention this. It's usually dealt with the different modes, theoretical mode. We can theoretically see what is happening to the objects in the universe, whether the universe is expanding, what will be its weight, etc. For this, the Einstein's theory, general theory of relativity, etc., can be used, and the Newton's law of gravitation can be used. Then we can also observe galaxies which are very far away, and also nowadays we can simulate it. Simulation means we are giving some data to the computer, and computer will work out and show us how the final stage of the universe will be. We are having a result of a simulation at the end of this talk. Maybe if I am reaching there, I can show you. So we can say that the beginning of observational cosmology started with the Hubble law. Okay, so we go into the next slide, and I'm telling about a Jesuit priest. So our Excellency was telling us about the great priests who were instrumental in bringing out new ideas in astronomy as well as cosmology. This George Lemaitre is a Belgian priest, and he brought in the idea of Big Bang theory of the origin of the universe. He was just imagining that if the Hubble's observations proves that all the galaxies are moving away, let us go backwards. Then at a further earlier time, these all galaxies will be closer together. Then it will be further closer. And like that, if we go beyond, we can say that all the galaxies did emanate from a particular point. So this idea that all the universe formed from a particular point earlier is his idea, George Lemaitre's idea, and this idea was ridiculed by his opponents. At that time, the most prevalent theory was the steady state theory, and the scientists who were proponents of that were very famous. So they were ridiculing him. So in a radio talk, one of the scientists were telling the steady state scientists were telling that the Big Bang theory was wrong, and he was nicknaming it as Big Bang theory. That the George Lemaitre says that some Big Bang did happen, so he was using it for ridiculing him. But this name stuck, and now the Big Bang theory is the most accepted theory of regarding the origin and evolution of the universe. So the Big Bang theory is like generally refers to the idea that the universe has expanded from a primordial hot and dense initial condition at some finite time in the past and continues to expand till this day. So I mentioned to you like this: from a point it started, and then it expanded. Galaxies were formed, and galaxies are moving away from us. So that is the idea. A common analogy is like when we are baking bread. നമ്മൾ ബ്രെഡ് ഒക്കെ ഉണ്ടാക്കുമ്പോൾ അതിനകത്ത് കിസ്മിസ് ഒക്കെ ഇട്ട് കഴിഞ്ഞാൽ ബ്രെഡ് വലുതാകും തോറും കിസ്മിസുകൾ അകന്നു പോകും അതിനകത്തുള്ളത്. അതുപോലെ തന്നെയാണ് ഈ യൂണിവേഴ്സ് എക്സ്പാൻഡ് ചെയ്യുന്നതെന്നാണ് ഒരു അനാലജി ഉള്ളത്. ഇനിയും നമുക്ക് ഒരു ചെറിയ ഒന്ന് രണ്ട് കണക്കുകൾ പഠിക്കണം. കണക്കല്ല, സംഖ്യകൾ നമുക്ക് പഠിക്കണം. ഇത് പഠിച്ചാൽ മാത്രമേ ഇനിയുള്ളത് മുന്നോട്ടുള്ളത് നിങ്ങൾക്ക് മനസ്സിലാവുള്ളൂ. അതുകൊണ്ടാണ് ഞാനിത് പറയുന്നത്. ഇത് ഇത്തിരി നേരത്തെ പറയേണ്ടതായിരുന്നു. നിങ്ങൾക്ക് അറിയാം പലർക്കും സൂര്യനിൽ നിന്ന് ഭൂമിയിലേക്കുള്ള ദൂരത്തിനെ ഒരു അസ്ട്രോണമിക്കൽ യൂണിറ്റ് എന്നാണ് വിളിക്കുന്നത്. ഈ ഒരു അസ്ട്രോണമിക്കൽ യൂണിറ്റ് എന്ന് പറയുന്നത് നിങ്ങൾക്ക് വേറൊരു ആശയം അറിയാം. സൂര്യനിൽ നിന്ന് ഇങ്ങോട്ട് ഭൂമിയിലേക്ക് so the light which is received in the earth, it takes almost like 8 minutes to travel from sun to earth. So 8 minutes is required for light to travel from sun to earth. So the sun to earth distance, one astronomical unit is this much miles or this much kilometers. This is equivalent to 8 light minutes. Means the light with a speed of 3 lakh kilometers per second will require some 8 minutes to reach here. 8 minutes means almost 500 seconds to reach us. So this distance can be represented as 8 light minutes, meaning light will take 8 minutes to reach here with this velocity. So the distance is 8 light minutes. This one astronomical unit is 8 light minutes approximately. Now there is another unit by name 1 light year. Light year is the distance traveled by light in 1 year. Light has got this much velocity per second, 3 lakh kilometers per second. With this velocity, if it travels continuously for 1 year, then it will travel a distance of 1 light year. So 1 light year is equivalent to this much kilometers if you calculate. And also if you give it in terms of a sun-earth distance, then this is this much of a sun-earth distance. Now I can mention to you that the nearest star to the sun is at a distance of 4 light years. So means that star, the light from the star is reaching us after 4 years. Nearest star, Proxima Centauri to the sun. That much away is the nearest star. So all larger and larger distances will come across. So you should be familiar with these terminologies. So just I want to mention to you one little idea. I mentioned to you that the nearest star is taking light from the star takes 4 years to reach us. So what does that mean? What we are seeing now is the light which traveled from the star from 4 years back. Means we are seeing the star as if it was how it was there. It was 4 years back. So one very great idea in astronomy, I'm telling you, that if you are seeing farther objects, then you can see the universe at a younger age. So when you are obtaining the light from the nearby star, we are actually seeing the star 4 years back. So if you are looking at a 150 light year away object, then we are seeing the universe as in the conditions when it was 150 years back. Likewise, all the galaxies are millions of light years back distance. That means if we are visualizing those galaxies, the light coming from the galaxies are actually showing us the conditions existed at that much earlier. So to study the earlier stages of the universe, it is enough to see objects which are farther and farther away from us. So to see objects farther and farther away, we require larger and larger telescopes. That is why astronomers always build larger and larger telescopes. The largest telescope existing on the surface of the earth is almost like it is having a 10-meter mirror. A 10-meter is a huge, it's like a large bus or something like that. So 10-meter mirror. And people are now building up the 30-meter telescope, in which India is also a partner. So 30 meters. It's not made out of a single glass, but glass will be tiled in order to make a 30-meter big structure to reflect what is the light coming from the sky. So what I am telling is, if you are able to visualize farther and farther faint objects, then we are seeing the earlier and earlier stages of the universe. This is observational cosmology. We see further earlier and earlier stages of the universe and see how the universe has evolved. So this is not the subject matter of our the common the way in which we are going in. But see, this 1 light year is a very important unit of distance. Then there is a further larger unit, 1 parsec, which is 3.26 light years. 1 kiloparsec is 1000 parsec. Our Milky Way galaxy is a 1 lakh light years across. Even our Milky Way galaxy is 1 lakh light years across. So we are going beyond this measure. We will be discussing about megaparsec and gigaparsec in our talk. So the extent of Milky Way galaxy is 31 kiloparsecs, in kiloparsecs if I say. And the distance to a nearby galaxy will be 1 megaparsec. And gigaparsec, 1 megaparsec is 1000 kiloparsec, and 1 gigaparsec is 1000 megaparsec. Please remember, please remember this. Now we go on to explain. We said that Edwin Hubble was the person who discovered that, or who could say that there are galaxies beyond our Milky Way galaxy, and these galaxies are all moving away from us. We are just then coming into these structures. I'm just going beyond the stars. Actually, beyond the stars we have gone, and now we can go beyond the Milky Way. Before that, I am just giving you some idea what a galaxy is. A galaxy is a huge gravitationally bound system of stars, gas, dust, dark matter, supermassive black holes, and other celestial objects. See, we know that this is a sort of or you should understand that this is sort of a spiral galaxy. All these white patches over here are stars. Multitude of stars, maybe billions of stars are there in a galaxy. We see most of them all together, huddled together. And these more brighter white regions are where star clusters are there, where a group of stars, maybe 10,000 stars are formed in one portion. Then that will look mostly like these portions. All this blue color is because of the forming stars. All this red color at the center is because of the stars which are at the center are very aged. They are almost in the end stage of their lifetime. But these are all young new stars. So this is sort of a spiral galaxy. You will just see this picture again. Spiral galaxy. What all are the components of the galaxy? Galaxy is held together by Newton's law of gravitation. And also there will be stars in it. The individual stars are there. And in between stars, there will be gas, hydrogen and helium, out of which these stars are made. And there will be dust. Dust is because there are some stars in the galaxy which might have formed earlier and which might have exploded. And whatever is inside might have come out as dust. So that dust will be there. Then there is some unknown matter by the name dark matter is there. Then at the extreme center, there is something very mysterious object called a supermassive black hole, which is actually million or billion times the mass of our sun, which is at a very small place, concentrated a very small place at the center. This very heavy black hole, we can't see it actually what is there. That's why it's called a black hole. So there is a black hole at the center. So galaxy is at the center a black hole. Then there will be stars surrounding it. There will be gas in between. There is dust out of the exploded stars. Now, galaxies are birthplace of stars, which are synthesizing all other elements heavier than hydrogen and helium in the universe. In the universe, in the beginning, only hydrogen and helium were there. You mathematics students will be studying also chemistry, I suppose. You know about the elements. Or in the beginning of the universe, scientists have proved that there were only hydrogen and helium, and of the universe, 75% were hydrogen and 25% were helium. All the other elements were synthesized inside stars. When stars gets aged, like our sun is actually now synthesizing its hydrogen into helium. Then it will go on and synthesize helium into carbon. Likewise, more other elements in this periodic table are all built up by stars. It was not there in the universe earlier. So, okay. So this is this picture of a galaxy. I mentioned to you that galaxy contains stars, gas, dust, dark matter, and supermassive black holes. There exist billions of galaxies in the universe. They are separated by distance of the order of many kiloparsecs, maybe even some megaparsecs. They are due to the gravitational attraction, these galaxies are coming together. All these minute things are stars. This is an elliptical galaxy. This is a spiral galaxy. These are two categories of galaxies. This is an irregular galaxy. This is some peculiar galaxy where you see a dust lane over here. This is originally an elliptical galaxy, but there is a dust lane there. So all of them are having a center supermassive black hole at the center. These galaxies were studied by Edwin Hubble, and then he classified them into the two major classes. One is the elliptical galaxies. He arranged it like this, and there were the spiral galaxies. They were of two types. Spiral galaxies which had a bar-like structure at the center. They were called barred spiral galaxies. So barred spiral galaxies were also of different types depending upon how tight these arms are wound around. So they are of four types. This is also of four types. So he found it very convenient to arrange it like a tuning fork. So all the normal spiral galaxies over here, all the barred ones here, and all the elliptical galaxies over here. So he did it like this, and this is called a tuning fork diagram. It has nothing to do with the tuning fork, but he arranged it in the shape of a tuning fork. So these are the various types of galaxies: barred spiral galaxies, elliptical, lenticular, and irregular galaxies. Okay. Now going to the next slide. This is the diagram again. I'm not mentioning anything. And properties of elliptical galaxies. Elliptical galaxies are mostly like an ellipse or a sphere, and it contains multitude of stars. And these galaxies shape may go from E0 to E7 depending upon its ellipticity. So for mathematics students, I need not explain what is ellipticity. The smallest can be 10% of Milky Way galaxy. There are small dwarf galaxies, elliptical galaxies, which 10% of Milky Way galaxy. And I am giving you here the image of M87, which is 54 million light years away, which is identified as one of the largest galaxies in the universe, big elliptical galaxy like this. And this is an elliptical galaxy example. This is a spiral galaxy. You have seen this. This is a sort of this is called a pinwheel galaxy, which is 23 million light years. Look at this distance, 23 million light years, so far away. But these are not distances in astronomy. Further and further distances we will discuss about. This is from the Hubble Space Telescope. I mentioned to you, Hubble Space Telescope is very famous in getting pictures, very spectacular pictures like this. So this has got a spiral galaxy, has got a central bulge, and then there is a disk. In the disk there is the spiral arms. On the spiral arms there are stars, and most of the known galaxies, 72% of the known galaxies are spiral galaxies. This is not because spiral galaxies are the most abundant galaxies in the universe. Actually, elliptical galaxies are more in the universe than spiral galaxies. But elliptical galaxies are very dim because most of the stars in it are aged and red. So we may not be able to spot many of them which are very far away. But spiral galaxies, we can see more of them. So this is an observational bias that the scientists have seen more of spiral galaxies. Okay. So spiral galaxies are thought to evolve into elliptical galaxies. These galaxies can collide each other, and spiral galaxies will finally become elliptical galaxies. So elliptical galaxies are containing more aged stars, and spiral galaxies mostly contain young stars. So spiral galaxies are younger than elliptical galaxies, so to say. Now we are coming to Milky Way. I told you that we can see Milky Way directly if you are looking at the sky. It may not be possible in the rainy season in Kerala, but if you are going to some very dark place where the sky is very dark and there are no street lights, etc., then maybe you will be able to see. Our forefathers might be visualizing the Milky Way every day, but we are unfortunately not able to see because of the modern revolution of lights the night is completely illuminated. So this is the Milky Way. I told you that this Milky Way was observed by Galileo at his time, and he found that all these regions contained a large number of stars which are closer together. So currently estimated to have 200 billion stars. So this Milky Way itself is having 200 billion. Billion means 10 raised to 9. So mathematics students know what 10 raised to 9 is, how big a number is. So 200 billion stars. Okay, now we are just seeing the galaxy in a better light. We cannot photograph our galaxy. Reason you may be knowing, it is very hard to selfie ourselves. If we selfie us from our front side only is seen. Back side or side, we cannot have a complete image of us by selfie. So likewise, we are sitting inside the inside Earth, which is a part of the Milky Way galaxy. So we can't take the whole image of the Milky Way galaxy. But so scientists have succeeded in taking various pieces and joined together to get the somewhat the image of a Milky Way galaxy. So this one and two another, it is 100 light, 100,000 light years or 31 kiloparsec is its size. Sun is on one of the arms here. Sun is not at the center, but it is on the spiral arms over here. Approximate position is here, almost maybe 2/3 distance to the edge. Sun is over here. And this is the neighborhood of a Milky Way galaxy. There are some dwarf galaxies, many dwarf galaxies which are there. See, there is a ruler given here. This much distance is 1 lakh light year. So this much distance is a Milky Way, and this may be some 5 lakh light years across. So in the neighborhood, these are the other galaxies which are just noted as a spot because they are very dwarf. They are only 10% the size of the Milky Way galaxy. This is not all the members, but I am coming to that soon. So Milky Way galaxy, I have shown you this image, and if you are seeing it from this side, from this edge, it will look like this. It will look like a cymbal. Cymbal is the musical instrument, and there is a bulge over here, and there is this disc shape, and these are the globular clusters which I mentioned to you. All these globular clusters should be isotropically distributed about the center. That gave the idea to Shapley that the sun is not at the center, but it is here. Sun is 27,000 light years from the center, and the whole distance is 1 lakh light years. Okay. Now this is the same. I just had another picture where the sun is pictured here, and the sun is a part of the Orion arm. These arms are having its own name, Orion arm of the spiral galaxy. Okay. Now, Milky Way galaxy is a barred spiral. It is categorized as SPB, and its size is 1 lakh light year, but it is equivalent to 31 kiloparsec. Thickness of the galactic core is 1,000 light years. It contains 2 into 10 raised to 11 stars, and there is a supermassive black hole at the center of a Milky Way galaxy, which is called in the direction of the star cluster Sagittarius. So Sagittarius A star. This supermassive black hole at the center is called Sagittarius A star because we can see the center of the galaxy is towards the Sagittarius star cluster which we see in the sky. In that direction, if you look, we will our vision will directly go to the center, but we cannot see by our eye anything at the center, but only telescopes can see. And recently, scientists have explored the center of the Milky Way galaxy, and they have found the clouds of gas moving here, etc. And this is about some such discovery. The gas within the disk experienced so much friction that it can reach 10 million degrees Celsius near to the center. It will be reaching 10 million degree. Now, there is a very important idea which scientists have recently in 1995 to 2016. This telescope of a 10-meter diameter. There is a twin telescope, my name WM Keck Observatory. This is at a height of 4,145 meters in the summit of Monarchy in US state of Hawaii. Hawaii is an island which belongs to US, and many of the world's telescopes are there because the condition there is favorable for putting telescope there. So there is this WM Keck telescopes, which are 2 telescopes of a 10-meter diameter, and these telescopes were completed in 93 and 96, and they were together used for scanning the portion of the central portion of our Milky Way galaxy, and that scanning did bring in the idea that the center has a supermassive black hole, and the scientists were able to find the mass of the supermassive black hole. These orbits of the stars were studied from 1995 to 2016. Some of the stars at the extreme center of the galaxy were studied in detail. And I mentioned to you these orbits and a simple application of Kepler's laws. See, there is a massive object at the center, and if you take a star, it will be moving around the massive object, which is a black hole. Then we can use the Kepler law to find what the mass of the central object. Particularly, there's some star called SO2 were targeted, and its period of revolution was 16.17 years. Now this is almost 20 years. So scientists were able to visualize SO2 for a one complete revolution and plus. So they were able to decipher the. See, you can see this video how they did. See, this star is moving like this. This is a SO2. This is the SO2 star. This one. All other stars are having a longer elliptical path. So within this 20-year period, this star has completed more than a full orbit. So they studied the star, and I'm putting it again. They studied this particular star and also the other stars, and from application of Kepler's laws, they could find the mass of the central object. Many stars are there, so they could repeat the experiment using the many stars and accurately find out the center, the supermassive black hole at the center. So that was a great achievement. This happened only a few years back, 4 years back or so. So we are coming to the next level of the structures. I mentioned to you that beyond stars, we can have different galaxies which contains lot of stars, etc. Then we can have a cluster or groups of galaxies. Galaxies are not uniformly distributed in space. They show a tendency to gather together. We also know that whenever people build houses, there may be a few houses in a particular locality of a village. Then there will be some paddy fields, etc. Then beyond that, there will be some group of houses, and all the houses may not be of a same size. Some of them may be big depending upon the financial status. Some houses will be very big. Like that, the galaxies also tend to be in some groups, and these groups, the galaxies are not also of the same size. So these are called either clusters or groups of galaxies. And we can see the local group. The local group is the group which contains our Milky Way galaxy and another bigger galaxy by name Andromeda galaxy, which is a spiral galaxy, and a large number of dwarf galaxies. Some of them you have seen around this in the earlier picture. Now these are all dwarf galaxies, which are very small elliptical galaxies, which are this is the pinwheel galaxy, which I showed you, the image I showed you, and that is also part of this. And these are all, it was Hubble in 1936 who indicated that our galaxy is a member of a group of galaxies, which is called a local group. Contains around 50 galaxies. Most of the members are dwarf galaxies. Milky Way galaxy is the second largest galaxy. The most largest galaxy is the Andromeda galaxy, and the Milky Way galaxy is the second largest. Because Andromeda galaxy is bigger than Milky Way, we can see Andromeda galaxy actually in the sky, on the sky, but we will usually see it like a star. But if you look at it through a telescope, we can see it like this. So maybe the only galaxy, large galaxy, which is visible to the naked eye is the Andromeda galaxy. It's because it is very large as well as it is near to our galaxy. We can see it, but we may not see the structure, etc., because it's very tiny. We can look at it through eye when it is very tiny, but with the telescope we can see it like this. So this is the neighborhood of a Milky Way galaxy, and this is called the local group, and it contains 54 galaxies. Okay. So this I just thought of showing you the fantastic picture of our neighbor, this Andromeda galaxy. It's very big. It's 2.5 times Milky Way galaxy. And this picture, you remember that this Andromeda galaxy, one particular star somewhere here, was used by Hubble to prove that there are external galaxies. Now, ironically, this is the image of a Hubble space taken by Hubble Space Telescope of the Andromeda galaxy. Okay. So this is a very fantastic image with all its details, etc. Okay. And this is approximately 4.5 billion years. Andromeda galaxy is a 4.5 billion light year away. 4.5 billion light year away means what we see as Andromeda galaxy, that light started from it 4.5 billion years ago. That means whatever we see as Andromeda galaxy, the light from Andromeda galaxy started when the Earth was just forming. Earth is only 5 billion years old. So Earth was just forming. At that time, the light traveled from Andromeda galaxy, and we are seeing it only now. So that means we are seeing Andromeda galaxy in an earlier phase of evolution of the universe. Okay. So the total size of the galaxy is 67 kiloparsec from here to here. And Milky Way galaxy was 31 kiloparsec. Okay. So I am just giving you a broader picture, like this is a local group, and the Andromeda galaxy somewhere here, Milky Way galaxy is at the center, and all other galaxies. The same picture I depicted in another way. Now, this we mentioned about one single group, which is local group. This is a farther away. You look at the scale over here, from here to here, it is 5 million light years. So this may be around, say, 30 million light years across. So at the center, we have this Milky Way and the local group. Then there are this NGC 5128 group away. And these are all different small groups which are in the neighborhood of our Milky Way galaxy and the local group. So I am just zooming out so that we can see more and more portions of the universe. So these are the nearby groups of galaxies. And just to show you a close picture of what a group is like. This is a very small group, which is called a compact group, maybe having only a few galaxies, 4 or 5 of them. So these are all spiral galaxies. This is called a Hickson group or something like that. Galaxies in the group undergoing a burst of star formation. All of them are blue. That means they are all forming new stars in it. So a few tens of galaxies will be there in compact groups. So compact groups are there. Now we can see galaxies within 100 million light years. So this is 10 million light years. So if you zoom back again, zoom out again, then from here it is 100 million light year. The million means 10 raised to 6. So 10 million until here 100, until here 100. So 100 million light years across. Then what all we can see the local group. Then there is this cluster of galaxies. See, cluster means a group of a larger number of galaxy members. If the number of members in a group is 50, then we call it as a group. If it is 1,000 or 500, we call it as a cluster. So group is a sub-classification of a cluster. So cluster of galaxies. In this picture, you can see various cluster of galaxies. This is a Eridanus cluster. See, all these points are various galaxies. Fornax cluster is here. And this is some Leo 2 group, Ursa group. This is the Virgo cluster, which is a very which is the largest cluster close by ours. Virgo cluster, which contains almost like 1,000 galaxies as members. So galaxy groups in this picture, there are 160 galaxy groups, and the large galaxies 2,500 are depicted in this picture. And also there are also some field galaxies which are not a part of any cluster. These are all called the field galaxies. Okay. There are 5 lakh billion stars. The largest nearby cluster is Virgo cluster. Collectively, all these groups and galaxies known as the Virgo supercluster. Earlier, this was all known as a Virgo supercluster and was thought as a supercluster to which we belong to. But later on, it was proved to be something else. We will come to that soon. Now, furthermore, it is shown here. I can go a little faster because it's almost time is running by, and the universe within 200 million light years is shown over here. You can see more of the galaxies, more of the clusters. This is Centaurus cluster, Virgo cluster, Ursa Minor. This is Hydra cluster, Puppis cluster, Fornax cluster. All of this contains a large number of galaxies in it. All these small white spots are actually galaxies. You can see some structure also here. There are places where there are no many galaxies, but there are places where galaxies are connected like a string. So we will discuss about this structure in great detail later on. So galaxy clusters are connected by thin strands of galaxies. There are also voids. These are called voids, and these are strands of galaxies. Okay. Now, cluster of galaxies contains few thousands or hundreds of galaxies. They are all gravitationally bound, and a few millions of light years. Size will be few millions of light years. This is a galaxy cluster Abel S1063. This is photographed by Hubble Space Telescope, and all these streaks of light which we see are not any kind of artifacts or anything, but this is for real. But this is because of a specific process of a gravitational lensing happening to very far away galaxies. We will mention, sometimes we may mention it, I'm not sure, maybe if he comes across we can say that. So there is a process called gravitational lensing, by which if there is a bigger galaxy cluster over here, and if there is a very far away galaxy, sometimes we have some quasars, and if you are visualizing, if it is back of this, then this galaxy cluster is capable of acting as a lens, and some images of that faraway object can be visible, and that is called gravitational lensing. Unfortunately, we are not having time to discuss any of this. So I am telling about the next hierarchical structure in the universe. If you go out and see, if you zoom out and see what is there, So we have the Milky Way galaxy, we have the local group, which is in which the Milky Way galaxy is a member, and then we have other galaxy clusters which are nearby us. This is this is the Virgo cluster, photograph of Virgo cluster. Closest large cluster of galaxies in the Milky Way. This is 48 million light years distance from us. And M87, I showed you the image of M87. This is at the center of Virgo cluster. This is one of the biggest elliptical galaxies in the universe. See how many galaxies are there. All these patches are because of small galaxies which are there. So thousands of galaxies, or maybe maybe many thousands of galaxies are there. Okay, contains more than 1,000 galaxies in it. So this is the picture of a Virgo cluster. This is another cluster, Fornax cluster. You might have seen this cluster in the earlier picture which we have seen here. Fornax cluster was somewhere here, no? Hydra, Cancer, puppies, Fornax. Here is the Fornax cluster. So that Fornax cluster is looking like this. This is 62 million light years, or the closest cluster to our local group, 62 million light years away, or 19 megaparsec from us. This galaxy cluster is 19 megaparsec from us. So central part is shown by this VLT, very large telescope survey. So very large telescope is a particular telescope which has taken the image. See, this is a very good, very specific spiral galaxy. See here, these are all elliptical galaxies. Okay. Now another cluster, Coma cluster. This is at a distance of 90 megaparsecs from us. We might have seen it in the earlier consolidated picture which I have shown you. Most of the galaxies that inhabit the central portion of the Coma cluster are elliptical galaxies. So the central galaxies of a cluster will be very large elliptical galaxies, and also smaller elliptical galaxies will be surrounding. So this is taken from NASA ESA telescopes, from Hubble Space Telescope, maybe from. Okay, this is another cluster which is a Perseus cluster, and the central galaxy is very special. It is called NGC 1275, and the central dominant galaxy, which is can be seen like this over here. The lot number of galaxies are there. Lot number of galaxies are there. So a galaxy cluster contains a very large number of galaxies. So the Perseus cluster, this is located 237 million light years away from us, contains over thousands of galaxies. Okay. So this is another cluster, Abel 1689. I'm not going into the details. You see the multitude of galaxies which constitute this cluster of galaxies. These are all held together by gravitation. And you can also see the streaks of gravitational lensing of faraway objects in this image. So these are all images of faraway objects, but they are distorted because of the lens effect of this cluster. Okay. One of the lensed galaxies was distance of 12.8 billion light years. So the advantage of studying these clusters is that if we study some of these lensed galaxies, these lensed galaxies will be very far away. See, 12.8 billion light years away. Actually, the universe is only 13.8 billion light year in expanse, or it's only 13.8 year old. So 12.8 billion light year distance means we are seeing this lensed galaxy which was there in the beginning stages of the formation of the universe. So this is one of the advantages of gravitational lensing. We may see objects which are in the earlier stages of the galaxy evolution. Okay, this is our cluster neighborhood. We have seen this, and this is 100 million light years. So this is across like a 300 million light years, 600 million light years across. We see all these galaxy clusters and voids over here. All this is called a Cygnus void, and this is another void. So this is a further zoomed out view of the universe. All these spots are galaxies. Now we come into the next kind of structures, which is a super cluster of galaxies. Super cluster of galaxies are clusters of clusters. Galaxy cluster itself is a cluster of galaxies, and then there will be cluster of clusters. Like a panchayat will form. In a panchayat, there will be some cluster of houses somewhere. Then there is another cluster out over there. There is another cluster of houses of another place. All together, we have a panchayat. Like that, all these clusters join together to form the supercluster. So cluster of clusters and groups of galaxies are superclusters. They are the largest known structures in the universe. Other than that, beyond that, there are no structures in the universe. Generally, they are a mass of 10 million billion suns, have the size of few hundred million light years. Only a few of such structures are already known. So this is very important to study the evolution of the universe. Now, Yeah, I'm showing you a picture which is a more zoomed out view of the universe. This is at the center we have this Virgo supercluster, and we have this Ophiuchus supercluster here. This is 100 million light year, and you can assume how much is this much distance. And here we can see some of the superclusters. This Pavo in the supercluster, Hercules supercluster, then Centaurus supercluster, etc. And you will come to the idea that many of these nearby superclusters are now joined together into one large supercluster by name Laniaca. This is an older picture. Now all these central portions will become a supercluster by name Laniaca. Okay. So Laniaca is the newly discovered local supercluster. So all these earlier separate superclusters are now a part of a Laniaca supercluster, and we are also a part of a Laniaca supercluster. This Laniaca supercluster was defined in 2014, very recent discovery by two scientists. And Laniaca in Hawaiian language means immense heaven. So they just put that name over there. So you might remember that Venus, Mars, etc. are name of Greek goddess or gods. So likewise, that practice has been continued, and therefore people usually adopt the names of astronomical objects in terms of mythological gods. It doesn't mean that the astronomy believe in gods, or they say that gods created the universe, or nothing of that will come into the scientific part of the astronomy. So in astronomy, everything has got a reason, and these names of gods is just taken like that, and by continuing an earlier practice. Okay, so you might have seen what this Laniaca supercluster is, and Virgo supercluster is now a part of Pavo Indus supercluster, etc. are a part of Laniaca. So this is the Laniaca supercluster, this in yellow, and you can see all other superclusters over there. Here, Corona, Borealis supercluster over here, Boot supercluster here, and there are Boots void over here. Then Capricorus void is here. So voids are there. Then there are places where there are a lot number of galaxy clusters are there. These are all joined together like this in a strand kind of thing. Here is a big supercluster over here. Okay, so Laniaca encompasses approximately 1 lakh galaxies over 160 megaparsecs. It has a mass of this much, 10⁻⁷ solar masses. Entire supercluster consists of approximately 300 to 500 known galaxy clusters. So this contains 300 to 500 galaxy clusters. Now I am coming into the discovery, our discovery. We discovered this Saraswati supercluster very recently, means in 2017. This is a picture of a Saraswati supercluster. This is one of the farthest superclusters, not the extreme farthest, but the second farthest supercluster from us. And this Saraswati supercluster was spotted from a particular image, which is an image taken by a telescope by name SDSS, Sloan Digital Sky Survey, which is a survey telescope which is in USA. So from survey telescope, the role of survey telescope, it will just survey the sky. Like people survey the land, it will survey the sky and leave the images there. And anybody across the world can take the images and work on them and can produce results. So that helped us in the sense we are not having such a survey telescope in India. So this data was available. And then we looked at this data, and our collaborator had some doubt that here there is a supercluster. And we were just analyzing that. 5 people were in our group, and we analyzed this portion. This portion altogether is called the stripe 82 region of the sky, because this was taken by STSS. The STSS takes many images, and the name of this particular image which is taken is stripe 82, some particular stripe of the sky. 82 is just a number, that's all. The 82nd plate which they might have taken or something like that. So this is not the supercluster, but only the central portion. I will show you that. And this is the SDSS, the Sloan Digital Sky Survey telescope. This is a major multispectral imaging and spectroscopic redshift survey using dedicated. This is 2.5 meter. They're not that big. 2.5 meter telescope. This is at Apache Point Observatory in New Mexico in the United States. So we didn't go there. We could avail the data from there because data is available to all astronomers in the world. So that data we took and we worked on that. And we could discover a Saraswati supercluster, the supercluster at this center. And continuing the practice of giving the names of mythological gods, we adopted the mythological god's name Saraswati to represent this supercluster in order to show that this was a discovery by Indian scientists. See, big discoveries, usually we see that there will be somebody from abroad in that. So we can proudly say that all the people involved in this discovery are Indians. So this is my collaborator and a faculty member at the Inter-University Center for Astronomy and Astrophysics, Joydeep Bagchi. And this is he standing just in front of the Paris Observatory. We visited the Paris Observatory, and his picture when he was there. And this is the lead member of a student member of the group, Shishir Shankyan. Actually, this discovery forms his thesis. He is now a postdoctoral fellow. And Prakash Sarkar was a postdoctoral fellow at the time, and now he works in West Bengal in an institute. And this fellow, you know for sure. Might be you will be seeing my video and you can understand that who is this. And this is our director of Ayuka, Shomak Rai Chowdhury. He is famous for discovering another supercluster, Shapley supercluster. So he was a part of the discovery of Shapley supercluster when he was in he was in Cambridge. He was in UK and he was there. He was a part of that discovery. And this Pratik Dabade is currently completing his PhD. He is also a research student. He was a part of this, and now he has got a many number of discoveries in his name. He is the person who has found out the largest number of giant radio galaxies in the universe, and his paper just got published. So we are the team which discovered the Saraswati supercluster, and the Saraswati supercluster is an extremely massive 200 megaparsec scale supercluster. This is published in this astrophysical journal, and in the next day almost 3,000 newspapers or news channels reported this. And there was a report in the BBC regarding this discovery of a supercluster by Indian scientists on that day. And during that time, when all these news came, we were, myself and Professor Joydeep Bagchi, we were in France attending a conference, and we came to know about all this publicity over here from there. Okay, these are all stories just I wanted to share with you. And Saraswati supercluster is the mass is about equivalent to 20 million billion suns, and size is 650 light years. Size is 650 million light years. It is written here. This much is the Saraswati supercluster. So this is 650 million light years. 1 million is 10 raised to 6. 650 million light years is the expanse of this supercluster. All the members of the supercluster is not seen to us because it is very, very far away. Or I will mention that again. So detected approximately 400 galaxies because of observational constraints. Like our excellency was also telling, and also the Muralidharan sir was telling, it contains 43 galaxy clusters. It doesn't mean that it contains only 43 galaxy clusters. It may have hundreds of galaxy clusters in it, but we could identify until now only 43 galaxy clusters. Others may be little faint or so that we are not able to identify. But the mass of the supercluster suggests that there are tens of thousands of galaxies, approximately 4,000 million light years away from us. 4,000 million means 400 crore light years away. I mentioned to you, this is the second farthest supercluster ever discovered. Okay, so if you are telling the expanse in the sky terms, if you look at the sky and if you are able to see this, actually we can't see this because this is very far away, then this will occupy, if we are able to see, then this will occupy like 20 full moons. You know the size of full moon. If we line up 20 full moons, that much of expanse will be there on the sky for this Saraswati supercluster. And this actually is in the direction of these Pisces or the Meenam എന്ന് പറയുന്ന നക്ഷത്ര സമൂഹത്തിന്റെ ഡയറക്ഷനിലാണ് ഇതുള്ളത്. ഓക്കെ, അത് നമുക്ക് കാണാൻ പറ്റത്തില്ല. So this is about the Saraswati supercluster and its position in the sky. So the detailed studies are going on, and also this was a question for your just for a light discussion. This question about the supercluster which was recently discovered by Indian scientists was a question for the Crore Pradi competition by Amitabh Bachchan. So this was a question for the 1 crore, and that person had obtained a 50 lakh, but he couldn't answer that, and he had to contend with the 50 lakh rupees at that time. It is just after 2017 when this discovery came. And also Amitabh Bachchan tweeted about this, and I had that copy. Unfortunately, I'm not having it with me. And there were a very large number of Indian scientists as well as politicians. Many people commented about this fantastic discovery from Indian side. Okay, and also this is well acclaimed in international circles. Now I am coming into the last discussion in this topic. This is about the structure of the universe. I have mentioned to you that the largest structures are the superclusters, and beyond that we have a structure like this. So this is actually images taken by telescopes. So this is some 2D of survey, and this is from the STSS telescope I mentioned to you. So if we join together all the different images which are taken by the telescopes and arrange it like this, we will see these are the universe like this. So this portion is actually avoided because of some reasons, because this is the galactic plane, and this it is not easy to get the images over there. So this is in a cone-shaped way. We have this the picture of the universe like this portion also like this. See, look at this. This is somewhat like a web structure. There are voids here, there are long strand of galaxies here. All of those are joined together. The same structure is here also, and here it has become lighter and lighter because this is far away, and many of the galaxies are not even visible to the telescope. So we have a sparser number of galaxies here. So wherever there is denser galaxies, we see a connection, filaments, etc., connecting between the galaxies and all. Okay, so there will be clusters, high concentration of galaxies, walls are there, filaments are there, voids are there. Voids are in between places where there is a lesser number of galaxies, and there may be wall-like structures. Three-dimensionally, we can say that it's a sort of a wall-like structure and all. And I am going into this discussion of a simulation of the universe. I have mentioned to you that the structure of the universe is also studied by computer specialists who are also cosmologists. What they do is they put in the initial conditions of the universe into the computer in the form of equations. Here comes the role of a mathematician or a computational expert. So all these particles inside a volume which they have taken, virtually a volume they have taken using the computer, the galaxies are given as a mere points over there. And then what is there is a attraction between the galaxies, and the attraction between the galaxies can be termed given in terms of Newton's laws of gravitation. And then we can from the initial distribution we can see what will happen at the next step after 1 billion year. Where will all these galaxies be? Many of them would have been attracted towards each other, and there may be some structures which might have been formed. So this kind of a step-by-step process, iteration process, can happen in a computer, and then computer can work out from the beginning of the universe till the present universe. And that is which actually happened for the first time in 2005 in Germany, where a supercomputer was working on the structure of the universe, and that simulation is called a Millennium simulation. So you can get more details from the web. Type in Millennium simulation. So what they did is they took a box kind of an volume, and they put galaxies in the form of a small dots in it, and then they connected it using mathematical equations, gravitational equations, and then they evolved the equations using computer algorithm, and then they could find what would be the structure after some particular era, and then they worked out till 13.8 billion years, which is the current age of the universe. And then they got finally from here it evolved into this, and then evolved into this. And these are called n-body simulations. Those who are interested in mathematics as well as computer science should listen to this. You have got a very brilliant future if you are becoming a simulation expert. So this is sort of mathematical modeling. Actually, what we are doing is mathematical modeling of physical things. And then this mathematical model is expressed in forms of equations. Only these equations can be worked upon by the computer. So computer see these are some equations which is to be solved. Then it will solve, and then if you are converting it back into an image, then you will get the physical picture. Likewise, this goes on. So how the distribution of matter in the universe is evolved over time, how it transformed into an observed population of galaxies and evolved into currently observed structure is given by this simulation, Millennium simulation. So this is a portion which was obtained through Millennium simulation. You can see all these strand-like structures, voids, etc. And a particular portion of this is expanded into this. And a particular portion is again expanded into this. And this central portion is again expanded into this. So this Millennium run is capable of giving us very minute details of the various portions of the universe. So they used more than 10 billion particles to trace the evolution of the matter distribution in the universe in a cube of 2 billion light years. So these cubes were taken as 2 billion light years across. Not exactly, but virtually 2 billion light years. And within these 2 billion light year cubes, they put 10 billion particles virtually, or mathematically they put 10 billion particles. simulation done by Virgo consortium of 5 countries using the supercomputer at the Max Planck Society, and is completed in 2005. It took 1 full month for the supercomputer, even for the supercomputer, to compute this. And this is the web structure of the universe, which I showed you in a larger, with a larger picture. This is the original observation which people did. This is the original observation, and this is the simulation. Look at this. This looks exactly similar. So this is a little more enlarged version. That's why it looks like this. All these strands, filaments, walls, etc., voids, etc., are all seen over here as well as in this picture. So this simulation is a very effective method of finding how the universe evolved. Because observationally, we may not be able to go into beyond a particular era in the evolution of the universe. So simulationally, we can. So we can do these simulations and compare it with observations and verify it like this. So this is the power of simulations now, power of computation now. And what we know about now is that the universe contains a large number of these kind of filament structures, etc. And there are voids also. And I can tell you that this structure is somewhat like a spider structure. ഞാൻ സാധാരണ പറയാറുള്ള ഒരു എക്സാമ്പിൾ ഉണ്ട്. പ്രേത സിനിമയൊക്കെ കാണുമ്പോൾ നമ്മൾ സാധാരണ 2 ഡയമെൻഷണൽ ചലന്തി വലകൾ കണ്ടിട്ടുണ്ട്, നമ്മുടെ മുഖത്തൊക്കെ വലയുന്ന പോകുന്ന വഴിക്ക്. അതുകൂടാതെ പ്രേത സിനിമയിലൊക്കെ പഴയ വീടുകളും മനകളും ഒക്കെ തുറക്കുമ്പോൾ അതിനുള്ളിൽ കാണപ്പെടുന്ന 3 ഡയമെൻഷണൽ ആയിട്ടുള്ള ചലന്തി വല നമ്മൾ കാണാറുണ്ട് പലപ്പോഴും. വവ്വാലുകളൊക്കെ ചെറുകിട്ടടിച്ച് പുറത്തോട്ട് പോകുമ്പോൾ നമ്മൾ നോക്കുമ്പോൾ പതുക്കെ ലൈറ്റ് വന്നു കഴിയുമ്പം മുറി നിറഞ്ഞിരിക്കുന്ന ചലന്തി വല. ആ ഒരു രീതിയിലാണ് നമുക്ക് ഈ യൂണിവേഴ്സിനെ കാണാൻ പറ്റുന്നത്, യൂണിവേഴ്സിന്റെ സ്ട്രക്ചർ. അതുകൊണ്ട് വെബ് സ്ട്രക്ചർ ഓഫ് ദി യൂണിവേഴ്സ് എന്നാണ് നമ്മൾ പറയാറ്. അപ്പോൾ അതാണ്. സോ ദി യൂണിവേഴ്സ് ഈസ് ഹാവിങ് എ വെബ് സ്ട്രക്ചർ. സോ വി ഹാവ് ടോക്ഡ് ഓൾ അബൌട്ട് ദി ഹോൾ യൂണിവേഴ്സ് നൗ. സോ I have made a journey from our earth to the extreme, the whole of the universe. I just wanted to give you a picture like this. And the supercluster which we discovered is a part of the structure in the universe, and it's an important aspect of the structure in the universe. I have one simulation to you. You can just see this simulation. This is another simulation which was done very recently with more ingredients, so that it is more accurate than the millennium simulation, and this is called a ASTERISK simulation. This will show you from the beginning of the universe until now how the structure, web structure formed. Please have a look. സമയം.
Thank you, sir, for your guidance and support. Then I invite Haripriya Ramakrishnan.
Just a minute. I will just finish now.
Anama, it is not over. It's being played.
Okay, it is just over. See, I'm just showing you the picture. This is the last slide. So we can see the components of the universe. The dark energy is 68.3% of the universe. The dark matter is 26.8, and only 4.9% is the ordinary matter, which is about which I was describing to you. All these dark matter and dark energy is not known to us. So I would like to end with what Muralidharan sir was saying. Anandamajnada Varnaniyam, ഈ ലോകോളം തിരിയുന്ന മാർഗം എന്ന് പറഞ്ഞ പോലെ തന്നെ we don't know much about the universe, only about this 5%, and that 5% even is so huge. So thank you. So my talk is over now.
Thank you, sir. We are proud of you.
I am sorry that I have surpassed the time, but I couldn't make it more consolidated than this. Sorry for it's almost 2:00. So thank you.
It was fine. It was taking us to a very just like Alice in Wonderland, sir.
Yeah, thank you, sir. Thank you. So I'll stop sharing, and if there are any questions, I can take it. Most of the people, some of them might have left because it is very late in the afternoon. Very noon. It's noon, 2:00.
So just a guess.
So maybe if there are not, actually we don't have time to take questions, but let the students send it to me. I have given my email ID in the
sir.
first page of the presentation, and maybe I have stopped sharing it. drjoephysics1@gmail.com. So hope you are hearing me. drjoephysics. drjoephysics. 1@gmail.com. So I can show it again. So just I'll show the first slide and it will show you. So we can end it over now. So this is there in my first slide.
Okay, sir. Dr. Joe.
So this is my ID, drjoephysics1@gmail.com. Hope you can see.
Physics at
So students, if you have some doubts, then you can either call me. My phone number also I can give you. 98460.
yes.
Those who are interested to call me, 98460 15011. 98460 15011. So all the best wishes for all those who attended, especially to the students. Mathematics is a brilliant subject, and it has got application in many walks of life, and particularly in astrophysics. I can say you authoritatively that mathematics is which is being used extensively to understand the cosmos. So welcome to the world of astrophysics. Thank you. I'm stopping my sharing. Okay. Please go ahead.
Thank you, Joe.
Thank you, teacher. Thank you.
Thank you, sir, for your guidance and support. The feedback form link is available on the chat box. Next, I invite Haripriya Ramakrishnan of second year BSc Mathematics for vote of thanks.
Good afternoon, all. As all good things come and end in life, is the webinar. On behalf of Department of Mathematics, St. Joseph's College, Pilatara, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this webinar on Beyond the Stars organized by our department. We want to express our gratitude to Honorable Chief Guest and Resource Person, Dr. Joe Jacob, who has spared his precious time for us and graced this occasion with his presence. We are also really enlightened with your knowledge. A warm thanks goes to our Principal, Dr. K.C. Muralidharan Sir, Vice Principal, Father Johnson Simeti, Manager, Reverend Father Dr. Joy Painadatte, Assistant Manager, Father Shijo Abraham, and our HOD, Professor Jacinda Luca Ma'am, for their enthusiastic support. A special thanks to our staff coordinator, Ms. Megha KP, student coordinator, Abhinav TV, teaching and non-teaching staff for their unflinching support and coordination. I would also like to thank teachers and students from various colleges who have joined in this session. Finally, in the end, a heartfelt thanks to our students for active participation. With these warm words and with a kind message, we move to the end of today's webinar. Thank you all for making this program a huge success.
Thank you.
നന്നായി സർ, വളരെ നന്നായിരുന്നു. വേറൊരു ലോകത്ത് എത്തിപ്പെട്ട പോലെ ഉണ്ട്.
ഓ സർ, താങ്ക് യു. അതെ, പിന്നെ ഞാനത് ഇപ്പൊ നമ്മുടെ കുറച്ചുകൂടെ സമയം ഒരു 1.5 മണിക്കൂർ ഉണ്ടാവുമെന്ന് ടീച്ചർ പറഞ്ഞത് വെച്ചാണ് ഞാൻ പ്രിപ്പയർ ചെയ്തത്. അതാ നീണ്ടുപോയത്, നമുക്ക് തീർക്കാൻ പറ്റാതെ. പിന്നെ ഹോപ്പ് ഇറ്റ് ഈസ് ഓക്കെ.
ഇനോഗ്രേഷൻ സെഷൻ കുറച്ചങ്ങോട്ട് നീണ്ടുപോയി.
എനിക്ക് കുഴപ്പമില്ല ടീച്ചറെ. ഞാൻ പറഞ്ഞ ചിലപ്പോൾ നീണ്ടുപോയതിന്റെ ഒരു കാരണം ഞാൻ പറഞ്ഞെന്നുള്ളേ ഉള്ളൂ. നമുക്കിപ്പോ ഞാൻ കുറച്ച് ആദ്യം കൂടുതൽ എക്സ്പ്ലെയിൻ ചെയ്യുകയും ചെയ്തു തോന്നുന്നു. അതുകൊണ്ടാണെന്ന് തോന്നുന്നു സമയത്ത് തീർക്കാൻ പറ്റില്ല.
ഇല്ല, അത് നന്നായി.
ഇതെല്ലാം ലേശം നീണ്ടു പോവാ സർ. ഇതൊരു അക്കാഡമിക് ആയ എക്സസൈസ് അല്ലേ?
അതെ, അപ്പൊ കുറച്ച് സാക്രിഫൈസ് ആകാം അല്ലേ കുട്ടികൾക്ക്?
പിന്നെ അത് വേണല്ലോ,
അതെ അതെ അതെ.
അല്ലാതെ എങ്ങനെയാ?
So nice to meet you, sir. Your scholarly speech, I liked it very much. സാറ് കുറെ കാര്യങ്ങൾ കണക്ട് ചെയ്ത് പറഞ്ഞത് എനിക്ക് ഭയങ്കര രസമായിട്ട് തോന്നി.
സാറ് ഇപ്പൊ അവിടെ സാറിന്റെ ഡിപ്പാർട്ട്മെന്റിലുള്ള കുട്ടികളെ ആരെങ്കിലും ഈ രീതിയിൽ ഇതിലേക്ക് വരുന്നുണ്ടോ സർ?
ഞാൻ റിസർച്ച് ഗൈഡാണ് സാറേ.
ചെയ്യുന്നുണ്ട്.
റിസർച്ച് സെന്റർ ഉണ്ട് ഇവിടെ. അപ്പോൾ എൻ്റെ കൂടെ ഒരു ആള് പിന്നെ വയനാട്ടിലുള്ള ഒരു സാറാണ്. സാർ എൻ്റെ കൂടെ ഇപ്പം PhD കംപ്ലീറ്റ് ചെയ്തു. വേറെ 4 പേര് ഇപ്പോൾ ചെയ്യുന്നുണ്ട്. പിന്നെ എൻ്റെ സ്റ്റുഡൻസ് IUK ഞാൻ പോകുന്ന പൂനെയിലുള്ള സ്ഥാപനത്തിൽ ഇപ്പോൾ ഈ കോവിഡ് കാരണം എനിക്ക് പോകാൻ പറ്റുന്നില്ല.